and then it bounces up or something like that. And it was scary because the kids were young, so I knew you could tell from the sky that something was crazy happening. And we huddled in the middle.
So anything that you say will be broadcasted.
And there's no way that I can see my notes on there, right? I can just use this.
I think we can.
It's fine. I can just look. I can follow along.
You sure?
Yeah, I'm gonna talk through most of it, but there's a couple of parts. Quotes and things.
1, 2, 1, 2.
1, 2, 1, 2. 1, 2, 1, 2.
Do you remember whether you signed the consent?
I did. No.
Where is everybody? I had trouble getting over here. So.
Yeah, it's just
How did
the
you get
streets.
over here? Did you walk?
I did walk. But we had lunch close by, so I just kind of tried it down here. It's wet. The streets are.
Oh, there are a lot of people here, but where are they?
I think we're just having coffee.
Oh, okay.
Yeah.
Okay, I guess I can have coffee too then.
Yeah.
You want anything? No, I can't bring you anything.
No,
Can I? Very strict in here.
It's a library. I mean, we could probably damage some things in here.
Oh, I know I would. Hey, I wanted to talk to you, not right. That's about what the topic you were going to get.
Well, not just now, that's okay, I'm absolutely drenched, so, but some, yeah, whenever I don't like it, but I'm dry. And I love to, that's the thing.
Rainy day, huh?
Yes.
I believe you'll be used to this software.
Yeah, Adam said it felt like late rain, it's on the daytime.
Got worse on
But my shoes felt like so before, so I was like, that's good.
Because I usually bring when I was using university students. For example, oh yeah. The same. When it starts raining, it forgets to stop.
Yeah. Did you hear your phone do an emergency siren over here? Yeah.
And it was funny because I was on the street and all the phones was ringing like this.
I'm not seeing thing for what's
I read a newspaper article in a paper that is responsible for feedback concerning weather, and they said that between 3 o'clock and 5 actually, and 9 o'clock, it will be the sun is rain. Like very windy with a lot of rain. It will keep on afterwards, but it will be smooth. Okay. So
You do be in here during that time, most
So
of
we'll
it,
be safe in here.
until the final hour of it, because we finish at 8 today.
I don't know if you came from the hill or from the part of the road. Highway.
Hard to, I'll show you.
We mostly walk downhill.
I'll show you, here's where you came from, that means anything to do with this.
So you were leaving Sedona? Yeah. Yeah. Is it so? There, and then you walk yes,
Well, that's not every, that you remember.
That was right where we.
Yeah, it's like,
Okay, I'm gonna be looking at that. That's great.
and also, so you did the highway, okay,
Yeah.
because I didn't work on the planning, people were planning station in the village, that way, if you stay the hill. You know.
Oh, same here, and of course.
Morning, Mr.
Where's your head?
Much better, thank you. Yeah,
I get bad headaches too, so I
Sitting
don't.
in my lost two goals, it's really annoying.
Mhm.
You're not gonna go to the Scotland. My kids back then, in Scotland, even happened.
Oh.
The third goal, there was so much celebration in the stadium, the commission on the week. The queues on the society sort of commission on the week. It's only ever happened once before, that was when Taylor Swift.
Taylor Swift.
Yeah, it's happened twice.
Yeah, what happened?
It was Scotland played Denmark, but qualified for the World Cup. When Scotland scored, the celebration, the impact, we measured on the Richter scale. Yeah.
That's amazing. I hear those soccer games can be dangerous.
Yeah.
Things like this.
Yeah.
People are crazy, right?
Yes, yeah, people sometimes get stabbed with them, right?
Yeah, that's more like a goal.
Yeah, that's like during the international, like, it's kind of nicer feeling, isn't it? Like,
The old
Scotland, right?
The old thing reaches and stuff.
Yeah, they're associated with like Catholicism and focus and stuff, and so you get this kind of like.
Wow, we're still fighting really bad.
Oh, yeah.
Yeah, these ones are all good.
Yeah. That's amazing.
Good morning.
We can find hatred anywhere. So.
New York and Boston, you can find it
Oh,
there.
absolutely. Speaking of that, I got the next lecture, about the United States and how bad it is.
Has he disappeared?
I think he went to the bathroom. No, I'm sure he went.
Yeah.
I always need to spend one day with pack his bags and go. There's so much of me that one day. I'm going to just gonna go to a conference together, he's gonna pack his bags and disappear. You did, you know, take care, you're awesome.
Water, so like a bit normal walkish,
Yeah.
it's mixed in, it takes some time, like kind of very.
You have the thingy.
Yes, it came.
Oh, no problem, thank you for waiting, that's just cute.
Good to see you guys.
Oh,
Okay, let's start. So our next speaker is Deborah Tollefson. She's the Catherine and Charles Frederick Professor of the Department of Philosophy at the University of Memphis. She's also the Vice Provost and Dean of the Graduate School at the University of Memphis. Deborah specializes in epistemology, especially social and feminist epistemology, philosophy of mind, social ontology, and collective responsibility. She has published numerous articles in these areas, and her work often employs an interdisciplinary perspective ranging over epistemology, philosophical psychology, and philosophy of mind, among other disciplines. Deb has also written an influential book on collective ontology entitled Groups as Agents, published with Polite Press, and she has also co-edited the Routledge Handbook of Collective Epistemology. And she's going to talk to us about a very advanced and interesting topic, which is mixture of agents and social epistemology.
Thank you very much. It's a pleasure to be here. I love these small conferences where people make these synergies, and I feel like I've learned so much. And it's been an opportunity for me to talk about or think about AI, which I'll sort of preface my talk by saying I had not given it any thought until I was invited a couple of months ago. And then, because life is the way it is, did not really turn to think about these things until maybe a month ago. So what I'm going to talk about may be old news to some of you, and forgive me for that. It's something that I found interesting as I was trying to figure out what's happening in AI, in the technology, and well, these are my thoughts on it, so you can see. So I do collective epistemology, which I think of as a subfield of social epistemology, and it focuses on and explores the possibility that epistemic properties and processes can be realized by groups. Today I'm going to talk about a new framework or architecture, depending on how you think about these things, called MOA or MOAs. You could have multiple MOAs. Again, I came across this by sort of doing what we do now, kind of Google, try to figure out what's happening out there in the world of AI. And there was very little on, groups in AI, but mixture of agents came up, and I started looking at the literature. So despite the fact that LLMs are not human agents, and the concept of sociality is perhaps not applicable to AI agents, the MOA framework implicitly contains several key insights from social epistemology. That the many can, under suitable conditions, outperform the few. That diversity of perspectives can, in certain circumstances, improve accuracy, and that epistemic properties can emerge from the interaction of multiple agents, especially under context of criticism and deliberation. So what I found reading these articles by computer scientists and engineers is that they seem to be hitting on a kind of anti-individualism that once you implement it in an AI architecture, provides for better accuracy, less bias, more coherency and accuracy. And given this, I don't think it's unreasonable, although we can talk about it, to propose that the epistemic gains of the MOA models confirm the validity of these central ideas from social epistemology and collective epistemology. And then I'll end, I want to talk about what additional insights might social epistemology offer and what might be missing from MOAs right now that philosophy or social epistemology might be able to help with. So I'm going to apologize to people who know this, but I'm going to start from the beginning, which I'm going to give you a short history, which it is short, of LLMs. So the early LLMs, these are dense architecture, right? They're neural, essentially networks. They're one big unified network with nodes, right? And you set the parameters by setting the weights. And you scale up by adding more parameters, and you just make the model bigger. Well, then you get scaling problems. What they realized is as the models got bigger, the costs increased and the model slowed down. So
what does MOE stand for?
Mixture of experts.
Okay.
Does it not say that there? Mixture of experts, do you see that?
Okay, now I just,
Yes,
sorry,
yeah.
sorry.
So MOE is the kind of next step. They thought, okay, look, within these networks, let's not activate the whole network. Let's kind of defer to some part of the network that's an expert. So each expert is its own small neural net specialized in its domain, and they have what's called a router, and it's used to determine which expert to appeal to on any given output. So math questions are sent to a subnetwork that deals with math, coding questions sent to the subnetwork on coding. The benefit of this, again, is that you don't activate the whole network, right? So you're not using as much energy. You're not slowing down the processing. It's built within a single model though, right? And then only that small part is used. So this did increase, this architecture increased efficiency and lowered costs by not using the whole network. In 2024, at the conference is called the International Conference of Learning Representations, which I understand is like the biggest growing network of computer engineers and computer scientists. There was a Professor Junlin Wang. Dr. Wang is at Duke University. When I looked this guy up, I think he came up with this when he was a graduate student. I think he's maybe 25 right now. And he gave this paper in 2024 at this conference. It was later published. So that's why the references here reference. In some of this literature, it's interesting, they reference, because it's happening so quickly. A lot of the work happens in conferences, and so they often just cite the conference rather than the paper. So that's, you'll see maybe in the references, there's confusion there. So he introduces this new architecture or framework. He sometimes calls it a framework, where he's going to look at the ways that we can kind of harness the benefits of multiple LLMs. So even if you add to an LLM the experts, you're still subject to random mistakes or hallucinations and bias, still have some scaling problems. So he and his group, he's got multiple co-authors, can we harness the collective expertise of multiple LLMs to create a more capable and robust model? Our answer to this question is yes. So he proposes putting together systems of multiple separate AI models or agents working together. Each agent is a full LLM model, often different models. So you could use Claude, you could use ChatGPT, you could use Genesis, and they generate answers independently, at least initially, or iteratively. I'm not going to be able to say that word, sorry. And then there's a coordinator, or what they call an aggregator, which combines their outputs. So here's a quote. I'm not going to spend time on that. You'll see this. If you look up MOAs, you're going to see this over and over again. This is from the paper. It describes the architecture and sort of what it looks like. So if you look at the first level, he talks about it as building it in terms of layers. And the first layer, you're going to have multiple agents, A1, A2, and A3. Think of those as their own LLMs, right? So ChatGPT, Gemini, and Claude. You're going to issue a prompt to them, all the same prompt. They're going to generate independently their own output. And then that output then goes to a next layer as a prompt. And at layer 2, you're going to have the same 3 or different models. Sometimes they have the layers swap out different LLMs at a different layer. And then you kind of filter the prompt through these layers. So here he talks about 3 layers, but the process can be repeated across multiple layers, with each round introducing further critique and comparison and refinement. And the goal is to converge on a response that's more robust, more comprehensive, and ideally more accurate than any single agent could produce on its own. He talks about the first layer as proposers, and they generate competing hypotheses or perspectives, and the later layers functions as aggregators. And he's very, when I say he, I mean this group of, I don't need to focus just on him. He and his collaborators talk about choosing certain LLMs for different layers. So some LLMs are better at aggregating, whereas others are better at synthesizing information. So he says that's very important. You want to kind of curate your collection of LLMs that you're going to use in the MOA. So what did they find when they developed? They developed 3 models, MOAs, using multiple agents, and they tested them. They used the 4 major assessments, Alpaca, Eval, does a kind of assessment in terms of win rate, where that's just judged by people. The system outputs something, an answer, and people judge whether it's accurate. The arena hard is how well, I guess, it answers difficult questions. MT bench holds how well it holds a consistent, relevant, logical conversation. And Flask is really comprehensive across a lot of metrics like accuracy, reasoning, quality, safety, helpfulness. And so they tested on all of those metrics, with all of those assessments, and they found that their MOAs performed better than any single LLM on multiple metrics. So here's a quote: "We highlight the inherent collaborativeness among LLMs, where models tend to generate better quality responses when they have access to outputs from other models, even if those outputs are of lower quality." Here is, can you guys see that? Oh, I'm not doing, yeah. So there's, sorry, I'm looking at my notes and the slides are not together. So that's, tells you a little bit about the findings. If you want specific scores, I direct you to the paper. I'm not going to show you like what percentage on each of those metrics, how the numbers in terms of what they did. This has been repeated over and over again. People have built other MOAs, and they show that it scores better on a lot of the metrics than just a single LM. Great. Okay, so this is just Flask, and this is the way they represent the results. And their MOA is the dotted line there. And this shows improvement in robustness, correctness, insightfulness. But it doesn't perform better on all metrics, but it did perform better on those three: robustness, correctness, and insightfulness. Again, if you look at other MOAs, it depends on the mixture of agents, how they're going to perform on these things. Some perform better on other parameters. They did say that this particular one was a little too verbose. So there's a
Conciseness.
Conciseness, yeah, it didn't do as well on conciseness, which I thought was funny. So, as I said, various models, MOAs have been developed since then. They've all shown similar benefits, epistemic gains. So now MOAs are used in a lot of other areas. They are slowly replacing, although I should say the cost of MOAs is not less, right? So they take a lot of energy. If you look at Claude is now using this MOA on the research mode, and it basically, if you go to this website, it basically says, look, don't use Claude for like how to get to a store. I mean, don't use the research mode in order to get to a store. You know, this is for like really important research, because it takes up a lot of energy, I guess. So it doesn't solve that, but it does seem to do really well in accuracy and avoiding certain kinds of mistakes. And part of what they found is that because either aggregation, and some of you, if you know the wisdom of the crowd literature, you'll know why, if it's an aggregation model, the errors kind of cancel each other out. I'll talk about that when I get to the wisdom of the crowds. And the deliberation models are really using the idea that critical evaluation from the outside, from a different perspective, can actually improve the accuracy of the output. And they talk about models as committees, where you get multiple perspectives. Okay. So I'm hoping at this point, sorry, I'm gonna go back. Whoa. Oh my goodness. Oh, that was quick. All right. Now can you get me back to where I need to be? Let's see.
No, just go, yeah.
Whoa.
Okay.
So sorry. Okay, so people use different models, either the aggregation or the deliberation model, and they have distinct benefits. The aggregation models usually help in terms of, let me see my notes here. They're very efficient and particularly effective for generative tasks such as summarization or creative text production. However, they have this limit. When agents share systematic biases or reasoning errors, redundancy may amplify those, right? If you've got a bunch of agents and all you're doing that are, say, trained on the same set, and all you're doing is aggregating their answers, it's not going to help you much, right? And so that was motivation to think about deliberative models. And the deliberative architecture addresses the limitation by introducing these structured interactions among the LLMs. You know, there's like, they're using it in multi-agents for it's kind of a, from what I understand, a role-based prompting. So they'll say, you know, you take the stance of the lawyer, and this other agent needs to take the stance of the defendant, and you know, or whatever. If you're thinking about kind of different perspectives, and then I'm trying to see what my notes are here. Self-refine is another one. It applies a critique and revise loop to improve coherence and factual accuracy. And then constitutional AI encodes normative constraints into LLM prompting as constitutional rules that guide iterative, corrections. Okay, so at this point, I'm hoping the social epistemologists in the room are hearing some familiar things. And it was strange to me that, at least, and again, I am just at the beginning of looking at this, but I read, you know, a handful or more of these articles, nothing explicit about social epistemology, you know, the discussion of deliberative models, you know, it's sort of gestures us at some political philosophy, but not really significantly. And so it was odd to me that there's a kind of convergence with some themes from social epistemology. And so here's some of them. I think there's probably more. So the Wisdom of the Crowds book came out in 2004. James Surowiecki is not a social epistemologist. This was a kind of popular book about collective intelligence. And I think epistemology has actually done less on collective intelligence. I think they don't like the word intelligence, for instance. I don't like it. I don't like the use of wisdom. But the collective intelligence literature is really interdisciplinary. So you get like social scientists and computer scientists, and they do things on swarm intelligence and stuff like that. So a lot of, it seems to me, a lot of what's happening is in the computer sciences, they might be appealing to collective intelligence literature when they're thinking about particularly the aggregation model, because the aggregation model in the MOA is very much like the wisdom of the crowd. Are you guys familiar with Surowiecki and the examples that he gives? No, you've never read The Wisdom of the Crowds. This is a great book. You got to read it. It's fantastic. So he starts out by quoting or telling the story of Francis Galton, who is at a country fair, and he is polling the villagers about the weight of the ox in the country fair. And he takes each of their guesses and he aggregates their, in some method, aggregates them, maybe adds them up and divides them by the number of people. And it turns out that it got very, very close, like within, I don't know, an ounce, a pound, or whatever, the aggregation. That is basically the idea of the wisdom of the crowds. And that has been used he gives really fantastic examples. This is a great example of where they couldn't find a lost submarine. It sunk, and they used a bunch of researchers who worked independently to find out where and then they aggregated and they found the sub. So lots of great examples. And so he argues basically that large groups of ordinary people, you don't need experts, can make surprisingly accurate decisions, often better than experts. So no expert could do it, but when you aggregate them, they can. But he's careful. He says, if certain conditions are met, and these conditions include diversity of opinion, independence of thought, and decentralization, and a good method for aggregating judgments. Averaging might not be the right aggregation method. So this has been taken up really in the collective intelligence literature, but we see aggregation a bit in the collective epistemology literature or in social ontology in the work of List and Pettit. If you remember, List is appealing to aggregation models. He was looking actually at legal cases where they're aggregating essentially the decisions of a jury on certain independent premises. And that's how they kind of motivate the view that in some cases, the group has reasons to act in ways that no individual should act, would act or would believe, form judgment. Yeah, they have judgments that no individual has, and there are collective rationality constraints. So this is the quote again from the Wang article. The finding of collaborativeness of language models, sorry, I'm still not where I should be. Finding of collaborativeness, that's one of the findings of the language models. We highlight the inherent collaborativeness among LLMs, where models tend to generate better quality responses when they have access to outputs from other models, even if those outputs are of lower quality. And that's something that Sirawicki kind of highlights too. You don't need experts. You can, simple, in many cases, aggregating the outputs of ordinary people will get you better results. Not always, though. So there are limits to the aggregation. There's a nice article by Miriam Solomon, social epistemologist, who talks about the ways in which groupthink can really impact. Her article is suggesting that in science, deliberation actually can lead to groupthink. And so we might prefer the wisdom of the crowd method, which is everybody works independently and then you aggregate. But aggregation, again, doesn't work in all cases. There could be a herding mentality, and they can become error prone, especially if the agents are not independent, working independently. Okay, so that's one insight from social epistemology that we see in this literature. The other is that epistemic properties sometimes emerge from interaction of multiple systems and are best ascribed to the system itself. And I appeal to some social epistemologists here, and Helen Longino is a really good example in her work. Objectivity is a social achievement. It's an emergent property that comes from interactions of individuals within a group. And so we see a follow-up article by Wang and his group appeals to the kind of collective intelligence of these MOAs. The third one I want to talk about is epistemic gains that arise from heterogeneity. Contrary to what they think in the US, diversity does matter. And, you know, there's all sorts of, you know, I don't need to tell you guys, this point is made all over the place in social epistemology. Medina also talks about epistemic friction, but we get it a lot in Longino, right? It's all from Habermas, essentially the role of critique. Philip Kitcher also has it in a different way than Longino, but he's pointing to the benefits of deliberation. And from Wang, here's a quote: "The diversity of model outputs is also crucial, and responses generated by heterogeneous models contribute significantly more than those produced by the same model, as we show later in section blah, blah, blah. By leveraging these criteria, performance and diversity, MOAs aim to mitigate individual model deficiencies and enhance overall response quality." And finally, critique matters. So you could aggregate different perspectives. Why does this happen? I literally cannot get back. Oh, I keep thinking it's a button that has two sides, but it doesn't, sorry. So you could, let's see, get diversity in the aggregation model, right? You have lots of diverse agents and you aggregate their output. The additional insight I think that you see is that, oh my goodness. Is that the deliberative model is critique. The role of critique is important because aggregating a bunch of experts isn't going to get you the accuracy unless you get them interacting together in a form of critique. So you see that as well. Okay, so those are the insights. I want to end by asking what's missing, right? What from social epistemology could we continue to add to the MOAs to kind of help with certain issues? We know from Longino's work that the structure of epistemic communities matter. And one of the objections, early objections to her work was, look, you can't let all the flowers bloom in science. We're not going to let in the flat earthers, right? They're not going to be a contribution. And so she said, look, not every viewpoint is something that we need to let into the discussion. There are norms that we all agree on, right? And we want to set up a community that has recognized avenues for criticism, shared standards for evaluation, right? The flat earthers are not sharing those standards, right? Because they're denying evidence. And responsiveness to criticism, and then what she called tempered equality of intellectual authority. I think there are ways that the MOAs might be able to integrate those. It's unclear to me at this point. You know, you might say the same thing. You know, people said, Longino's view just lets a lot of bad stuff into science. And you might think that's exactly what's happening in MOAs is you're getting a lot of bad stuff in there. So why, you should be able to exclude things that you think are not going to increase the accuracy of the system. So I think we need to think about whether there are ways in which you could structure the MOAs for accuracy where you're kind of making exclusions in appropriate ways, I guess. And then one of the things that comes out of Longino really is that the role of critique is really important, but critique is not just a cognitive thing. Like the diversity issue is not necessarily just cognitive, right? The diversity comes from social situatedness. So it's because I have certain experiences, it's because I'm in the world in a certain way that I bring a certain perspective. And you might think that LLMs are limited in terms of being able to provide that socially situated perspective. And so you might think that MOAs are simply a kind of peer review inside a paradigm, right? They're just putting forward the same evidence that they all have and the same presuppositions, but there's no possibility for transformative knowledge in the way that Kuhn thought, right? You're not going to have paradigm shifts. And of course, without paradigm shifts, we would not have science, right? We would not have knowledge, right? It's only when somebody really disturbs the status quo that we actually generate kind of what Longino will say is transformative knowledge. Now, I was thinking about this last night, and I was thinking about Oresti's talk. If you think about the LLMs as extended systems where they include the engineers, then you have a kind of socially situated aspect of the system that might contribute what's needed for transformational knowledge. But certainly more could be said about that. And that's it. That's all I have.
Thank you.
Sorry.
Okay, questions? John.
Thanks, Deb, that was really interesting. Could you talk? Oh, thank you, sorry. Could you talk more about Longino's reply to the 1,000 flowers bloom problem? Because not kind of objection or anything, I just wanted to hear more because in some ways, shared standards for evaluating claims, I mean, depending on how seriously you enforce those shared standards, you might think, well, now you're losing a kind of element of diversity, which was actually getting you some benefits, right?
Yeah.
And then same with, depending on what you mean by responsiveness to criticism, criticism makes you shut up.
Yeah.
Then you're, again, it seems like a tension.
Yeah.
Between, these solutions, are they taking away the benefit that you were getting? And then in terms of the tempered equality of intellectual authority, I didn't catch what that meant.
It's basically how you weight the expertise. It's like the notion of expertise. So you might listen more carefully to somebody who has a lot of experience. That doesn't mean you don't listen to the novice. but you might weight, certain inputs more heavily. I think actually LLMs could do that in terms of weights, so.
So for example, that seems to those three, again, it's not an objection, it's trying
Yeah.
to think about how these things interact, because those 3 points by Longino seem to, in some ways, just undermine the whole point of the wisdom of the crowd dynamic, and then also, like Kitcher's division of epistemic labor.
Yeah.
Is that the right way to, is that the right
Yeah,
way to think of that
so-
Kitcher framework? I can't remember.
Yes, yeah. But I mean, Kitcher also has ways of excluding, he doesn't let everybody in either.
Right.
I mean, I'm not saying Longino, she tries, and a lot, the criticism has been that what you've raised, that it actually undermines, or that it doesn't do enough to rule out the flat earthers, it's a fine balance. I don't know that I can say much more at this point. Honestly, I haven't even gone back to look at her work. I've just been focused on trying to figure out what MOA is. And so I think I'd need to go look more, find out what those parameters are and whether they could be used or are already used. Expertise, it seems like, could be weighted in the LLMs. She is not concerned with the aggregation at all model. She would say that's not going to get you anywhere. So she's just focusing on the scientific context and critique. There was a talk on the first day, sorry, I'm totally forgetting, about trying to get rid of false statements or, falsity in the LLM. And somebody over here mentioned the value of false information. Do you remember that? She was talking about, when you publish scientific results, oftentimes it's false stuff. The results are, and it's valuable for science. I mean, I take that to be, Kitcher and Longino would say, yes, in fact, it is. And I think philosophy of science, when I read this stuff and I think about LLMs, particularly MOAs, it suggests that we don't want to rule out the false stuff in the system, because it can, in fact, cause people to go directions that they wouldn't have gone. And maybe in the MOA, it causes the system to go in directions that it wouldn't have previously gone. So, yeah.
Yes, ma'am.
Actually, this is super interesting stuff. So I can see 2 studies in computer science that would be really cool to do. So the first one you mentioned, as I understood, so that's really the deliberation model. So you have some elements are really good at one task, others another. So you kind of distribute the labor, and then collaboratively they reach a better result than any of them would have done so on their own. That's really nice, because then it's kind of non-summative results for an LLM. Now, secondly, it'd be really cool if, what you were saying about the wisdom of the crowd, whether you did a similar study and then let each of the models reach the conclusion, and then use an aggregation rule and to see whether that was, say, more accurate than each one of them would have done on their own.
Yeah.
That would also be a nice thing to.
Yeah,
I assume the answer would be yes, but that would just be nice to kind of show
Yes.
that for computer scientists.
Yeah.
So you don't have the distribution of labor, you just send them off on their own, and then
Yes.
they'll have to be more reliable than not if you talk about accuracy.
They-
And just let them reach the conclusion, then aggregate. That would be a nice study.
Yeah, they have done that.
Yeah.
Some of the initial studies, right? So
Yeah.
they just have them work on the LLMs
Yeah.
come out on their own, and
So that should show that. And thirdly, it's just picking up what you said that last week, which was John. So the Paul Spark, he's one who, he has this idea of Machiavellian intelligence, so that.
yes, I read that.
Yeah,
It's
so
great.
individual biases will sometimes on the right condition translate into virtues at the collective level.
Yes.
So you talk about falsity. If there are other biases you could find in an LLM, like biases or such like
Yes.
errors of reasoning.
That's
what
great.
have you.
I'm gonna go
But it was
back to
really helpful
him.
to see if computer scientists could show that in a study that a well-known tick, maybe one update, a really bad performing one, and then you add some really powerful cunning ones in the mix, and then see if that could somehow add any value at the collective level on either the aggregation model or the, maybe not so much that one, maybe the distribution model would be more interesting.
Yeah.
I'm just seeing all these analogies with work in social science.
Yeah.
Because you're saying, and there are other people like Alan Haskell talks about the virtue at the collective level of having individual, agents reason on their own.
Yeah.
This lovely paper in HAP, I think so similar along similar lines. There's loads of stuff there to explore. It's super interesting.
Yeah, thank you. Yeah. That's fantastic.
Please.
Thanks. Yeah, that was great. This may be a bit too technical, so no worries if you don't know the answer to that. But one thing that struck me as sort of a point of the sort of connection between the wisdom of the crowds and the aggregation-based models. So when you were talking about the wisdom of the crowds, you were saying how there might be certain constraints, and not every aggregation method might work. So it might not just be a question of taking an average or something like that. And I was basically wondering whether the aggregational models, the LLMs, they are under any constraints when they aggregate. If so, what they are, and if not, whether that might be basically some reason for thinking that there is less of a constraint on the aggregation method, because we have now evidence from these LLMs that they're more accurate anyway, even with no constraints. I don't do they do it in a particular way that is coded in or that they've figured out that satisfies these constraints that allegedly there are? If yes, it might be interesting to see what they are. Maybe we can learn more about what's going on in the wisdom of the crowd stuff. And if not, maybe these constraints that are allegedly there are not that important after all.
Right.
I don't know what to do with that. But it's
I don't know the details of they talk about an aggregator, and if you go online and you look up, there's a whole bunch of videos of guys, it's white guys talking about buying, how you can use this, you can get an aggregator. I think I gave you the link to Together AI is one of them. And I haven't looked carefully to see, and I'm not sure I would understand exactly what they're doing for the aggregation, but I suspect it's different. Yeah, as you say, it could be an average, it could be, I don't know, other ways of aggregating. Sorry. Yeah.
Hearing from.
Yeah, thanks a lot. So I'm a bit of a skeptic about this aggregation. I've always said I don't like the crowds. I like smart people. Basically. So I always suspected that that what's really doing the trick there is that what you actually mentioned, that the mistakes are being cancelled.
Yes. Yeah.
But LLMs, they're so clever, they don't need to make mistakes. So I'm wondering whether we should rush into putting LLMs together in a room. We might have to do that with people because they make mistakes and maybe, they cancel each other out. But shouldn't we rather just build LLMs that are clever and clever, that don't need to be together in a room holding hands in order to cancel each other's mistakes out, but rather to take whatever features, whatever Claude has, and whatever features Gemini has, and build a clever LLM, call it Mona, that is able to do both.
Yeah. I guess that if you believe that in some of the ideas about criticism and diversity that, if you build a single model, you're not gonna get the outside. Your point might be like, well, it won't need the outside, right? I think that the bias though, think about Kuhn, right? If you build an LLM that's even better and it has it's still within its own paradigm, right?
Yeah, so I'm not a big Kuhn fan in the
Are you
ranking
a
of.
fan of anything?
I am a fan of very many things, it's just not a Kuhn. So I like the truth, I don't like when there are many truths. I like when it's one, that's kind of, simple-minded things is what I like. So I think.
I think the idea is that
Yeah.
one system is gonna be biased,
Yeah, so
right?
I think that if you have good reason to think that a Kuhnian worldview is the correct one,
Mm,
then I completely agree with you. But at that point, I think we might need the flat earthers as well, because the next flat earther might sound like a flat earther, but actually they're the next Einstein, right? So
Yeah.
in that case, let's put the flat earthers in.
Yeah.
I think there's a lot of research coming from Bristol. I like my philosophy of science in Bristol that suggests that the Kuhnian kind of theory is not quite the best explanation of the data that's taken to motivate it. Basically, this folks know a lot about history of science in Bristol and they feel of science. So I trust, I don't know anything about it. I just take it clear, and I believe them. So some conditioning. So if this folks in Bristol are right, that the Kuhnian paradigm was a bit of a rushed exaggeration for the data that motivated it, then I think in that case, we should, just build a clever AI that's good at finding the truth. Because there's no reason to assume that they will have the cognitive limitations that we have, and that give us this wisdom of the crowds thing that makes us better. So they are just limited creatures, they don't need to be limited. And to the contrary, if we do have reasons to think that Kuhn is correct, then we should go all in and allow flat earthers as well. So I think that's kind of made the more moderate.
I'm not committed to MOAs. I don't know why the computer scientists have gone this way. They've gone this way because they found the LLMs to be limited. And instead of building a better LLM, they have thought, let's put them all together and see what happens. And so that's sort of what's the status of things now. I think your point is an interesting one, especially when you think about the cost of this. But I think building a better LLM, you get the scaling problem, right? You're just getting a bigger and bigger system that uses more and more energy. Part of what I gather from the literature is that the MOAs can be task specific as the LLMs are. And so you could build a little MOA that did a certain kind of thing using the LLMs. I just think I don't know.
It might be that actually there's no perfect LLM to be built, and with all LLMs that we could ever have, putting them in the same room would give us better results just because of their cognitive limitations, just like what happens with humans. So maybe that's something that we can discover from the armchair. But that I think is only conditional upon us not being able to build a perfect. Which of course the perfect human is hard to build, but the perfect might be still possible.
They do think that MOAs have the possibility of the same thing that human beings have, which is groupthink, right? So that point about the structure of the MOA is really important. And whatever critical, if you're going to do the deliberation model, you have to have diverse perspectives, because otherwise you're just going to, whatever you put into the system, you're going to get out the same stuff instead of something new.
I think John had a finger. Sorry, John had a finger. Sorry, I was thinking my own stuff. John.
Yeah, sure. So
I don't think Mona's idea of just build the best AI that, that's gonna be best at getting at the truth, I don't think that's inconsistent with what they're trying to do here. The idea that the M of A model is like better, right? So, like, if you just think of it in terms of like
It's a group
trying to
agent.
build the best architecture, isn't the idea that, at least what these guys are arguing, or these people are arguing, is that the mixture of agents architecture is actually outperforming
Yes,
the
yeah.
more older
You know,
architecture.
my point was maybe about individuation or something, so my thought was that you need to put you and me and Deb in the room if you want to get a better philosophy paper, just because you can't take my brain and Deb's brain and put it in your head. It doesn't work that well, but with LLMs, you can do that, so
Yeah.
why put us, why
So
put
that
three
is
LLMs in a room?
What
not
you're
just-
describing is the MOE. That's
Right.
basically what they did in the MOE. They said, look,
So it's the
certain
MOE now,
aspects. Yes, some of the aspects of the system are experts. And then they work, you kind of distribute the labor. That's an MOE. But they found that, as you try to scale up, you still have those problems. And you have hallucinations and things like that. And so they thought, okay, well, let's think about it not as a single agent, right? They're thinking about it as a group agent.
Yeah.
And I do think they're appealing to kind of wisdom of the crowd stuff. But as they found limits to the aggregation, they've added the deliberation.
Adam. Yeah.
Thanks a lot. I just had a question about wisdom of the crowds and the constraints on it, and how to think about that in connection with wisdoms of the crowd and why they end up being reliable and working.
Yeah.
So like some of the constraints, right, at least decentralization,
Yeah, they have to be
independence of judgment,
independence. Yeah,
and diversity of opinion.
yeah,
Right?
yeah.
So when you build in those constraints, like in the bull example that you gave, it does seem like one fact about that particular, inquiry is that no matter how dumb you are, or everybody can size up a bull and make a judgment about it. If you take a complicated case, so take, take like maybe some of the hardest open problems we have, maybe like the computer science, I don't even know how to, the P versus NP problem, which apparently people think won't be solved for hundreds more years, even with computers. So if you just pose that problem and it's a clean one, it's like P versus NP, is it true or is it not? P equals NP, is it true or is it not? And then you do a big wisdom of the crowd thing, and you've got all those constraints met. Do we have any reason, based on what we know about wisdom of the crowds, to think that that would be a reliable way of getting to the truth about that question? Because it seems to me that if wisdoms of the crowd worked on P versus NP as opposed to the bull, it looks like it would be completely just a matter of luck that it would work in that case.
Right. So aggregation doesn't work for all kinds of questions. So that's the limit of it. And I can't, it is, the aggregation stuff is really just error cancellation. And, they talk about, you have to have the right numbers of people as well, right? If you just have two people giving their opinion, it's not. So it's all about the math in the aggregation case. And these other difficult questions, that problems cannot be solved by the aggregation. And nobody in the collective wisdom or collective intelligence stuff thinks that the crowd always is accurate. It depends on the question. It just, in certain circumstances, the crowd, the many, are better than the few.
Just one quick follow-up. Would you think that the way to delineate the circumstances where the crowd is better than the few, do you think it would have anything to do with whether or not the target question is one in which, well, doesn't have to be a theory here, maybe like even though, right, there's a diversity of opinion that includes different competence levels presumably in the crowd.
Mhm.
Do you think there's like maybe a minimum threshold for competence with the concepts that feature in the question or something like that?
Yeah.
Is that the dividing line maybe for when
Could
we
be.
should expect wisdoms of the crowd to be reliable versus not?
It could be. I don't know. Honestly, I haven't gone back to Sarah Wickie's book to figure, what.
I'm gonna check
But
it
if
out.
you look at his examples, they are pretty diverse. But it's, I couldn't tell you, I'm trying to think of some of the other examples. Like, the submarine case was stuck out to me. They're not always just these simple questions. You raise a good point that I need to think about, and probably the computer scientists need to think about, under what conditions is the aggregation model better or worse than the deliberative?
Do they need to be more reliable than not?
I'm sorry.
Do the individual members need to be more reliable than not? Be more likely to get it right?
That's consistent.
Yeah.
So that's,
something that this talks about all the time.
Yeah, so, they don't necessarily need to be, right? They don't need to be, you can have cases where, you aggregate people who are not particularly reliable, and the aggregation is, they can be non-experts, or they can be their judgment is false, but when you aggregate, you get something. Now, if they were all false, probably not, but yeah.
Yeah, I had a follow-up that was roughly the same as Jesper's. I think you need to have some positive reliability, at least on some kind of interval of the sort of thing that you're judging on. Because you can have any number of people making guesses on a fair coin toss, and you will just not get be able to predict the right result for this random occurrence, right?
Right.
But if you're guessing the weight, right? Even people might be very unreliable about the specific weight, but they will be reliable for certain intervals.
Yeah.
It's more than 1 gram, this odds, right?
Right.
And some people will have a smaller interval that they're reliable on. And you can see how with that, eventually you'll be able to home in on the right sort of thing, right?
Yeah.
But if it's just random, it's going to be bad. If you take a throw of the die, that will, if people converge on something, it's just going to be some kind of bias in favor of some number, right? And if it comes out like that, it's going to be purely an accident, right? Where you're not predicting anything.
Yeah.
So you need some kind of reliability.
Yeah, I think a lot of response to this book in particular, and some of the collective intelligence stuff, is along those lines. That's why I don't like the word wisdom. There's no sense in which the collective is wise, especially if, they're not, I'd have to go back and look, honestly. I haven't had time to do that, but I don't remember the thresholds that he's talking about, like what kind of competencies do the contributors have to have.
Hearing the presentation, I was thinking about the usual conversation we have back and forth concerning publications. Usually, in sciences that use experiments in order to manage public, means that you have faced a lot of failures. Usually, they're a great deal part of the work, more than 60%.
Mm-hmm.
And what is considered truth is only when you have faced the right results, and then you're supposed to publish. So there's no aggregation regarding the process of failure, which basically it's not the same as false. It's a process that you understand, you learn, But in the end, for many reasons, the result might not be the one you were searching for. And there's always an open question, okay, one or more people achieved to find a solution and have a proper result or response. But what happened about the rest of the efforts that are made? And the result or not, or the argument was not the one that we were seeking. And that's also an open question. So I think that hearing the conversation, I believe another gap with MOAs, and especially MOAs, is how you will try to aggregate the failure, the concept of failure, in a distributed or community level. And this is something we already face in a difficulty in science. Because failure doesn't necessarily mean a false response to something.
Yeah, I don't know that I have a response. You know, I mean, the LLMs have a lot of failure in them in the sense that they're trained on stuff produced by humans. So you already have a system that has a lot of false stuff in there. Probably has a lot of true stuff in there. So I don't know if that gets at what you're getting at. I mean, there's, yeah, I don't know. I'm not sure I know how to respond.
So I found on this actually very interesting, and I think it presents a very nice opportunity for social epistemology, this kind of mixture of anything. So just a few thoughts also about cancelling out bias. I think it is necessary to have a mixture of agents to do that, because we do know that LLMs inherit bias that is inherent in the training data. And so I suppose that if you kind of combine LLMs, then this is gonna, at least to some extent, cancel out the biases, which we know really exist. You did mention that because humans might be involved in the training, humans might have biases or may fail to detect biases that they have. And so I was thinking, yeah, it would be great to combine an American element with a Chinese element, but in this case, probably cancel out biases that we're not even aware
Right.
that exist, in a sense that, yes, we are talking about the communities that are separated in a Kuhnian sense, right? Completely different mentality, a way of seeing the world. So I think it's going to be necessary that it cannot be done MOE style. It's got to be MOA style. So I definitely see value in that. I also think that you're definitely right when you say that all these guys go for these solutions without even thinking about any of what social epistemology has to say. And it's weird because they went for some kind of aggregation model that we don't really know how it works, but they also went for a deliberation model. The question is, and it's been very prominent in the discussion now, which kind of approach is useful each time? And so I think social epistemologists are needed to try and map what kind of problems might require the right kind of collective approach. And so I think, I'm going to say that in public, I don't care. This kind of research, I think, presents an excellent opportunity for some kind of research project on computational social epistemology, where we get to collaborate with people like that from computer science, and we treat each LLM as an individual agent, and then we can try and see, depending on the problem that we're facing, which kind of collective solution fares better, and then try and also like help our theorization of these problems, but also generate the right kind of mixture of agents, like the kind of social technical philosophical engineering that I really love thinking about. I think this kind of stuff, yeah, it's a great opportunity for us in social epistemology.
Yeah, I think that's interesting.
We
I don't know. I mean, I think that there's, this is relatively recent stuff. So 2024, although, it's just changing rapidly. So Claude put in place their MOA in, I think I said June of 2025. And they're using it for all sorts of things. Some of the references I gave, they're using it to in public policy, right? To look at how to make public policy across multiple agencies more coherent. So it's a lot of that's not an aggregation, right? That's where they're using the deliberative model. So they're trying to get, those are sort of analysis of text, really, where they're trying to get complicated text to cohere and to be a kind of unified voice across multiple agencies.
Yeah, so for instance, I was thinking that the wisdom of the crowds, I mean, going by the two examples that you gave, one the weight of the ox, the other the location of the submarine that is lost, both of these instances are cases where people who might have some knowledge have to guess. So now we need to have a good estimate of what the value of something is. So it seems that in this case, it's the wisdom of the crowd when you just aggregate estimates. And pretty much in the way that Chris also described, you probably like calling the right
So the ox case is just a guess, it's random, they're just guessing. I don't know that you could use a crowd multiple times to get the same answer, right? If they're just guessing, you wouldn't have a reliability of,
I don't think they're entirely guessing though. I mean, no one's gonna say it's a dog. I mean,
okay, that's
right?
fine.
So it's not just like crazy opinions.
Yeah. I mean, the submarine case are people, those were experts, I'm pretty sure.
Right.
And so they had some reliability on their own, you would think.
Right.
So, yeah, I mean, they're all really, I highly recommend the book. It's fascinating. And then there's a lot of literature on the swarm intelligence.
Yeah. Let me just specify this and give it yes. So Condorcet's theorem says that if you have several individuals, each of which has just barely above a chance percentage to be right, so just 0.51, and also they're independent, and also they don't, I don't know, sometimes they cannot affect each other in other ways, then the bigger the number of the voters, the faster you're going to converge to the right solution.
Yeah, so that's what I said, the number of votes matters in some cases too.
Of course. So, but when they say that like above chance percentage, so below chance is a completely random guess that, they might say that an ox weighs 2 pounds.
Right.
And then the closer you get to 1, like 0.80, then maybe you're an expert. But if you're just like 0.51, you're not an expert, but you're not just any crazy person who's going to respond to anything.
Okay.
That's the way I think to think about what's going on with the mathematics there.
Okay.
But I'm just saying, like, trying to figure out all these different ways of collectivizing opinion or, I don't know, some kind of guess or the deliberative model or the least empiric model, they all seem to be very useful across different situations. And all of these can be used to come up with a different mixture of agents. But we can also use this approach to test what we think about all this kind of thing. And I really think that's a good opportunity. So
I mean,
it's something to really go into.
yeah, I do worry that, you know, if that organization itself is saying, look, this is a heavy load on the networks, like, don't use Claude for superficial stuff. I worry about, like, I don't want to use it to do philosophy because I worry about the environmental disaster that we're forming.
What if you had an R&R and you had about a week?
Yes, sir.
Yeah, just an afterthought. So a couple of weeks ago, I learned that there's a view in neuroscience called it's called society of the mind. So the idea is really very similar to the deliberation model that happens in the human brain.
Yeah.
This is fascinating. I never knew. So you have neural processes that collaborate with control signals to reach a decision on what to be done.
Nice.
So they are distributed, they act together on principle, working memory and so on. So it's very similar to that sort of thing, and they can leverage some of the effective wisdom of the crowd in the argument that's been argued for that.
Yeah.
So epistemology has been social all along. There's always been units collaborating even in human brains. Fascinating stuff. Yeah, little bit I know.
Yeah, I mean, isn't it sort of homuncularism? You know, has that view. John Biro has a paper called "Persons as Corporations."
Yes.
Yeah. Similar. But it does get to the point where you're like, well, what's the appropriate level of description? So, you know, you have an individual agent, and within the individual agent, there's multiple agents.
Yeah.
And then you could build up, you could have multiple, I don't know. You could think of the MOA as a single agent. It's just a collective agent.
Okay, well, thank you very much then.
Thank you.
Okay, so coffee break, and we're back at 4:15.
The lens communicate.
Epistemology, not as much as you, because I'm not doing philosophy,
Together.
They could.
Because we don't really know how that collaboration is
Our
like.
understanding.
Yeah.
Well,
It's more efficient.
but they have another language that they use to communicate. That they created on their own. If I had been this time, I would have been much more creative in book, but what I did in a book that here.
Would you say stuff that might?
Everybody does stuff that shows that alleged results didn't quite work, but that's because James Layton is someone that you might want to read, but he's quite formal. But there's plenty of literature that, I mean, look, so here's how it works. You see some data and you think, this data seems to suggest that this theory is correct. And that's how it goes into us, that's how it works in science as well. And that's never true the first time you come up with it, right? So then people come and say, well, actually, here are 683 other theories that could explain the data just as well. And what we need to figure out now is basically what the best explanation is. That's how we do it last week, that's how we do it in science as well. But there's nothing wrong with coming up with with the first theory and with the fact that that theory is very usually mistaken because, the more you evolve, the more time passes. It's a bit what Leb was saying. The more of us that been looking at that evidence and more positions in the model space have occurred to us. So then, of course, 2,000 years from now, we will have better theories than we used to have 2,000 years ago. That's not to say that, Plato and Aristotle were idiots. You're awesome, right? I mean, I don't think you and I are as clever for our times in terms of the theories that we produce.
No one's
They were
gonna do it
there.
as impossible. I'm right.
You're just saying.
I think that
I'm a fucking
one
dummy.
theory
This is
that
the
already,
question.
I was just looking.
Exactly.
much relating.
This is a no idea. I've been to the future, I know stuff.
That no one is around that idea.
Έχει τα εξαιστικά και θα τα περάσουμε. Δεν χρησιμοποιήσω αυτό. Χρησιμοποιήσω αυτό αν θες. Δικό μου. Ωραία, τέλος. Ωραία, αυτά τα μενάζω εδώ, τα έχεις κλίκια. Να σου φέρω ένα Είσαι έτοιμος? Να το κάνεις?
Ναι, δεν ξέρω κατά πόσο ταιριάζει.
Πες τα δικά σου και θα δούμε. Άμα τα πεις έτσι ωραία όπως τα πεις τότε με τον Εισαγγελαριάδη θα είναι τέλεια. Πάμε να πιούμε λίγο καφέ. Έλα, ορίστε. Yes, I'm coming.
Να σου πω, με ρωτάει ο Καπάνης, προσπαθεί να μπει στο online.
Ναι, πρέπει να μπει στην τρίτη ημέρα, day 3.
Οκ.
Να του πεις. Είναι 3 days, πρέπει να γραφτούμε για την τρίτη ημέρα.
Now I'm going to show you a special article from in New York. His name is
Sono i face, leggi dove fotografi e είναι τα microscopes και τα λοιπά. Ευχαριστώ πολύ.
Μια υπογραφή στο τέλος, δεν έχει άλλο.
Την υπογραφή είναι και το όνομα σας ολόκληρο. Ναι, αυτό. Ευχαριστώ πολύ.
Όλα καλά.
Ναι,
Το έχουμε.
αυτό δεν ξέρω. Ήρθαμε εκτός και με
Πού πούμε, εδώ που είμαι. Αλληρό. Πήγες στην έπρεση εκεί πέρα. Ωραία, καλά το κάνεις. Και πάλι να πούμε, δεν σου έκανες κακής.
Όχι, όχι, κοντά.
Ξέρω, δεν πρέπει να είμαστε μοσχάτες, δηλαδή πρέπει να είμαστε...
Δεν τα ειδικό είναι το φάνηρο μόνο λίγο, δεν είναι πολύ καλά το άτομο μέσα εκεί πέρα.
Οκ, εντάξει. Okay, so our next speaker is Vangelis Triadafilou. He's an assistant professor of philosophical logic in the Department of Philosophy at the University of Ioannina. He graduated from the Department of Mathematics at the National Kapodistrian University of Athens and completed his postgraduate studies in philosophy of science at the Department of History and Philosophy of Science, again, of the University of Athens. His doctorate dissertation focused on non-classical systems of logic for vagueness. He has published papers in scientific journals on topics such as non-classical logic and its applications in philosophy, Aristotle's syllogistic and its interpretation, Frege's logic, the set theoretic paradoxes and foundations of mathematics, and he's going to talk to us about emergent structures in foundation models. Thank you very much.
Thank you. Okay, so my subject, as Orestes said, is going to be concerned with emergent structures in foundation models. And I'm going to make a poor attempt at investigating whether we could attribute some sort of understanding.
Sure. And so there we go.
Yes.
Okay, needs to be the rest of it.
Okay, so whether we could attribute some sort of understanding to today's models. So my aim, contrary to appearances, is quite modest. I'm going to merely suggest that depending on how one understands understanding, certain components of it, or at least of some analog or proxy concept, can plausibly be found in today's AI models. Furthermore, that philosophy research regarding understanding in AI must go hand in hand with computer science research in interpretability. So let us start with some preliminaries. First of all, what is a foundation model? So according to Stanford's Center for Research in Foundation Models, a foundation model is any model that is trained on broad data and such that it can be adapted to a wide range of downstream tasks. And further down, they add that the sheer scale and scope of foundation models from the last few years have stretched our imagination of what's possible. And while many of the iconic foundational models are language models, the term language model is simply too narrow. The scope of foundational models goes well beyond language. And some examples of foundation models. So as we all know, all modern versions of ChatGPT, Claude, Gemini, and so on are multimodal large language models. And we also have unimodal large language models, vision language models, detection models, that, given a sentence, can detect objects in an image, segmentation models, diffusion models, and so on. All of these foundation model categories make essential use of certain basic architectural components. And these mainly are multi-layer perceptrons, convolutional neural networks, transformer blocks, and so on. Now, each of these different architectures brings with it different inductive biases. So we may treat each of these as carrying with it different assumptions in regard to the kinds of patterns that are likely to matter. Each choice of architecture will tend to notice different patterns in the data we feed it with. In regard to multi-layer perceptrons, in other words, fully connected networks, this is a general purpose, low bias architecture. It carries next to no assumptions in regard to the structure of the data. It simply assumes that the input can be treated as a generic vector. So it has no structural assumptions in regard to locality, spatial structure, and so on. So, for example, if we train multi-layer perceptron in image classification, it will not inherently know that nearby pixels are related. Nevertheless, this is something that it may come to know, but it will have to come to know it through training. This is not something that a priori it knows through its structure. So these properties make multi-layer perceptrons very flexible, but also very data hungry. So a visualization, which you all have seen. We have here a hidden layer of new neurons and an output layer of K neurons. Each layer is of the form H equals F activation of W times X plus B, where X is here a p-dimensional input vector, B an e-dimensional bias vector, W an e times P weight matrix, and F activation a nonlinear activation function. Usually, for the non-input layers, the activation function is going to be a real function. For the output layers, it's going to be a softmax function, as softmax can convert logits into probabilities. So here, the matrix W and the vector B, in essence, contain the layer's trainable parameters, the tunable nodes, as we say, which we may tune in our effort to lower the loss of the function. By combining many such layers, in essence, what we are doing is we are composing functions of this form. So if we go back to this visualization of a neural network, in essence, this is just and assume that the hidden layer here uses ReLU activations and the final layer softmax activations. In essence, this is nothing more but a visualization of the function shown here at the bottom of the slide. On the other hand, convolutional neural networks are characterized by a strong bias towards locality and hierarchical spatial composition. So the basic assumptions here are that local patterns matter. The same local pattern may occur anywhere in the image, and that more global patterns are composed of more local ones. This makes convolutional neural networks excellent for computer vision tasks, where they are much more efficient than multi-layer perceptrons. However, their bias towards local compositional patterns necessitates increasing the model's depth if we wanted to be able to handle global patterns. And as we know, depth increase does not come cheap, as it makes it harder to avoid the vanishing and exploding gradient problems. Okay, so here a visualization of the basic function behind convolutional layers. In essence, these networks learn specific filters, which they slide over the feature maps of previous layers in order to produce the feature maps of later layers. And visualization of one such network. So notice here that the image being fed to the network is of dimensions 224 times 224 times 3. So the first two coordinates are the image's height and width, and the final coordinate are the image's channels. So this is an image composed of 3 channels, because it is an RGB image, so it has one channel for red, one channel for green, and one channel for blue. And notice also that as we move deeper down into the network, the spatial coordinates progressively get smaller, while the channel coordinates progressively get larger. And we may think of this as the channel coordinates, in essence, encoding concepts which progressively get more and more global in scope and more semantically rich. And finally, the backbone, one could say, of today's models is the transformer architecture, which is characterized by very strong bias towards a relational structure among input entities. However, transformers carry much weaker built-in assumptions about locality than CNNs. So, in other words, they can track global structure from the very start. So, relations between input elements are brought to the forefront here of what the model attempts to track. And furthermore, the context of each token is not simply a fixed local neighborhood of it, as in the case of convolutional networks, but the context is built dynamically based on learned relevance. These are properties that make them ideal for natural languages and natural language processing tasks, as, for example, they can handle anaphoric and cataphoric devices quite efficiently. And of course, the basic mechanism behind the transformers is the mechanism of softmax attention, where each token embedding fed through the input to the model is multiplied with a learned query, a learned key, and a learned value matrix. And the result is that each token embedding fed as input to the model is split into a query, a key, and a value vector. Then, through the attention mechanism, each token may absorb information from whatever other tokens are deemed contextually relevant. So here, a visualization of the attention mechanism. The queries and the keys determine which positions should be attended to. And this, as a result, produces the attention matrix A. And the resulting attention distribution is then applied to the values to produce the output of the attention layer. In essence, here, the highlighted query vector interacts with the key vectors of all the tokens in the context window of the model in order to produce a distribution of attention scores, which are then multiplied with the value embeddings of all tokens in the context window, producing in effect an output which is the weighted sum of the value embeddings of the tokens in the context window. And of course, we may have two different kinds of attention. We distinguish between self-attention, where both the queries and the keys and the values, they all come from the same sequence, and cross-attention, where the queries come from a different sequence of embeddings than than the keys and the values. And of course, we all know the visualization of the encoder-decoder transformer from the Attention is All You Need paper. To the left is the encoder part, to the right is the decoder. The decoder is the part that autoregressively outputs the sequence of the model, while applying masked self-attention, where each token attends only to the previous tokens, as well as cross-attention to the contextually updated embeddings supplied by the encoder. Now, some specific examples. One particularly well-known model is the BERT model. This BERT stands for bidirectional encoder representations from transformers. And this is an encoder-only model. Its purpose is to give an input sequence to produce contextually updated tokens. Now we can actually load it. So I've taken the liberty to load it here. And the model I've loaded, we can see here, possesses 12 encoder layers. Its embedding space is of 768 dimensions. And its total learnable parameters it has in total, this particular version of the model, 109 approximately million parameters. Now we can feed it sentences. For example, here I have fed it this particular sentence here. Notice that it has two occurrences of the word there. And here we can see how the model takes the sentence, breaks it up into tokens, and next to each token we can see one initial segment of the corresponding embedding taken from one particular layer. Now, each embedding is in essence a vector that lives in a space of 768 dimensions. But we can apply dimensionality reduction techniques in order to take the embeddings of the tokens and project them into a three-dimensional space. So here I have applied principal component analysis, and we can actually produce a visualization of the 3D distribution of the embedding tokens. Here we see their positions in the embedding space, approximately, since this is just a projection into a lower dimensional space. And we can see the relative positions when we are at layer 0 of the model. Notice here how the embeddings for the two occurrences of the word there are almost together. However, they do not completely overlap because the model also adds positional embeddings, and in this way manages to distinguish between the two occurrences based on their position. Next, as the model successively applies through its different layers attention, it updates the coordinates of its embedding token successively by having each token absorb contextual information. And we can actually visualize this. And here we see the movement of the embeddings as they absorb more and more contextual information. And we can see here that in the last layer of the model, the embedding of the one occurrence of the has moved away from the embedding of the other occurrence. And we can actually see that, in essence, the embeddings are broken up here into two clusters. And in this cluster, we can actually see that it reads the chef made pizza. Or in other words, or alternatively, chef made the pizza. While here are all the anaphoric devices that are connected with the word chef. Now, this is one particular example, and some results that pertain to BERT that have been obtained in the last years. For example, it has been found that the updated token embeddings, if we extract them from BERT, capture information that is sufficient to recover syntactic trees. It has been found further that BERT encodes information about entity types, relations, semantically roles, and so on. However, it has also been found that it struggles with representations of numbers. Now, BERT is one foundation model, is an encoder-only model. Most LLMs make essential use of the decoder part as well. So we may have encoder-decoder language models. In an encoder-decoder model, the encoder reads the input sequence and produces contextual hidden representations. And then the decoder generates the output autoregressively while cross-attending to the encoder's output. On the other hand, GPT-type models, are decoder only. So the input sequence in a GPT-type model is passed to the decoder, and this uses then masked self-attention to condition on the previous tokens, while autoregressively predicting the next token. We repeat this process to generate the output sequence. The next step is to move into vision. So it was after the publication of the Attention is All You Need paper, it was quickly found that transformers may also be applied to vision problems. So 1 year later, a paper was published that applied transformers to problems of computer vision. So for example, in the VIT architecture, an image fed to the model is broken up into patches, and these patches are projected into an embedding space, which is then fed into a transformer encoder. The transformer notices global and local relations among tokens and feeds the contextually updated tokens to an MLP classifier that produces the final distribution over classes. And once we reach this level, the next level is to just go multimodal. So here, for example, we see a visualization of the VILT architecture, where a transformer encoder is fed both word embeddings and image embeddings, and it can later be used to, for example, answer questions regarding the content of an image and so on. Now, in regard to emergent abilities, before we move on to talk about emergent abilities in LLMs, let us mention a few experimental results regarding emergent abilities in non-LLM models. A known VLM, CLIP, which uses contrastive laws to align image and text representations in a certain embedding space. And it can be used for tasks such as zero-shot image classification, image text retrieval, and so on. So it was noticed recently that the model can, in effect, be steered to talk about specific image regions just by appropriately placing a red circle on the image. So if we want the model to talk about a specific place in the image zone, all we have to do is, not all, but one part of what we have to do is just place a red circle on that particular part. And somehow, even though the model was not specifically trained on this task, it will somehow understand that we wanted to talk about this specific region. Now, this is something that was discovered. The model was not trained to do this specific task. And furthermore, it was discovered that the ability to do that is influenced by the model's scale. So as the model scale increases, so its ability to do this becomes better and better. So here are some examples taken from that paper. So depending on where we place a red circle on the image, the expression that receives the highest scores changes. So we can steer the model to talk about different things by just placing a red circle on various parts of the image. Now, the authors explicitly frame this as an emergent ability and as an ability that shows that VLMs possess an ability to learn from rare events. So as they write in their paper, presumably, the VLMs understand red circles out of the box because they appear sufficiently frequently in the training corpus, i.e. the internet. Our analysis shows that red circles are indeed present, but they are rare. It is a testament to the extraordinary capacity of VLMs that such behavior can be learned from such rare events without an explicit focus on doing so. And further down, they note that only the larger models exhibit this behavior reliably. So here we have a VLM that, as we scale up its number of parameters, it emerges an ability to be able to be steered in regard to the part of the image on which it's going to talk by just a red circle. Furthermore, they note that emergent behaviors also bring risks. So as they write, we note that the ability of VLMs to learn, even from rare events, such as red circles, can acquire both desirable and undesirable behaviors. Red circles, in particular, can have a negative connotation in the training data, as they are often used by news outlets to mark missing people or criminals, and evidently, the model learns from such examples. The examples are few, but they are there. And here we have an emerging ability that leads to the model exhibiting unexpectedly hidden stereotypes, stereotypes that were hidden in its training dataset. So here, for example, to the left, the model is being supplied a picture of a man and a woman without any red circle. And as one would expect, the expressions that receive the top scores are the expressions woman and man. But if we move to the next picture, it just takes to place a red circle over the man, and now the expression that receives the first, the highest score becomes murderer. Or if we place the red circle on the woman, now the highest scoring expression again changes, and now the highest scoring expression becomes missing person. So this is, we see here a hidden bias in a few examples in the data that the model was trained with, exhibiting itself as an emergent behavior in cases that those who made the model didn't expect. Of course, since VLMs such as CLIP have been trained on vast amounts of image text data, they can be adapted to a variety of downstream zero-shot tasks. For example, one application of CLIP is in image anomaly detection, which is crucial for industrial applications. So through appropriate prompt engineering, the CLIP model can be used for detection of anomalies in images. Now, of course, the paradigmatic case of emergence in today's foundation models are indeed the emergent abilities exhibited through model scale in LLMs and MLLMs. So here is a passage from a particularly well-known paper in the field. As they write, it is now well known that increasing the scale of language models can lead to better performance and sample efficiency on a range of downstream natural language processing tasks. In many cases, the effect of scale on performance can often be methodologically predicted via scaling laws. On the other hand, performance for certain downstream tasks, counterintuitively, does not appear to continuously improve as a function of scale, and such tasks cannot be predicted ahead of time. And then they give their definition of emergent ability. We define emergent abilities of large language models as abilities that are not present in smaller scale models, but are present in large scale models. Thus, they cannot be predicted by simply extrapolating the performance improvements on smaller scale models. They also note that many language model families, even when we increase their number of parameters, the examples contained on the training set, the examples they are trained on, they remain the same. So in many cases, when we increase the parameter scale of a language model, the amount of data it is being trained on remains the same. And in a recent paper on emergent abilities, Berti and al. Note that the phenomenon can be understood through an analogy to phase transitions in physics. So we have a system here that undergoes a sudden qualitative shift in behavior once a critical threshold is crossed. Performance often hovers near random until this threshold is surpassed, at which point a sharp jump occurs. This unpredictability makes it difficult to foresee emergent abilities by simply extrapolating from smaller models. And it also raises fundamental questions about the complexity and nonlinear scaling behavior of LLMs. A striking example is 3-digit addition accuracy. A model with 6 billion parameters achieves only 1% accuracy. A 13 billion model improves slightly to 8%, but a 175 billion model suddenly reaches 80% accuracy. This stark contrast between smooth loss improvement and sudden task-specific breakthroughs highlights the enigmatic nature of LLM scaling. And another paper from Anthropic shows, here are some diagrams from this paper that show emergent abilities in 3-digit addition, language understanding, and program synthesis. Note that in all these cases, we have an emergence in regard to the model's ability to perform these tasks at around 10 billion parameters. And as they note in the paper, it is not clear when or why this happens. There are various theories, of course, but we don't, the community hasn't really converged into one particular explanation of the phenomenon. Now, one specific case of an emergent ability is in context learning. So, since transformers, and therefore LLMs and MLLMs, rely on attention, they can efficiently compare, retrieve, and combine information which is present in their context window across various layers. Now, this, in certain cases, allows them to perform tasks for which they were not explicitly trained, simply by placing the necessary information within the context of the model. So, in context learning is exactly the ability of the model to infer and perform a task from instructions or examples provided in the input context, a task which it was not specifically trained on, and all of that without updating its parameters. This allows for few-shot transfer applications of the model to new tasks. For example, here is one particular example of in-context learning. Here the authors simply supply the model with pairs of English and German words. They don't add anything else, and the model has to, from this, understand that the task is to translate from English into German. So in-context learning is one particular type of emergent behavior. Bigger models are better at in-context learning. And a variant now of in-context learning is known as chain of thought prompting. And this is a method which is being used by current models to enhance their reasoning capabilities. So in context learning, the model is fed with tuples of the form input, chain of thought, and output, where a chain of thought is a series of intermediate reasoning steps framed in natural language. So it has been found that, given a few such examples, sufficiently large LLMs can manage to generate their own chain of thought. So instead of predicting the last result in one step, they generate the intermediate steps of the computation. Later tokens may attend to the earlier ones, and in this way, the model manages to treat its context window as a working surface. And this leads to high improvements in the reasoning abilities of LLMs and MLLMs. Here we see, for example, one such example of chain of thought prompting taken from this paper. The model is supplied a series of questions and answers, and in chain of thought, the answers to the questions also contain the intermediate steps of the calculation. So in the end, when the model is prompted to output its answer, what it does, it also includes in its answer the intermediate steps of the calculation. Given that the model autoregressively outputs its answer, and each token has the chance to attend to the previous tokens and absorb information from them, through chain of thought, in many cases, the reasoning abilities of LLMs are enhanced. So in this example, for example, while the model failed to give the correct answer with standard prompting, with chain of thought prompting, it managed to predict the right answer. And here are some graphs showing the improvements of some of these models with chain of thought prompting in datasets that have to do with mathematical and logical problems. So we see that in some cases, the improvements are quite spectacular. In some cases, not in all. Other methods that also take advantage of the context of the model's context window and that are applied in today's reasoning models is the scratchpad method. And here are some graphs showing improvements in performance over some tasks. For example, notice here the performance in 9-digit accuracy in addition, where the model, no matter what its parameter count, the baseline model stays close at 0. But then by adding a scratchpad, in effect a working surface where the model can output intermediate results, its performance skyrockets. Of course, still, this is something that is dependent on the scale of the model. We don't see this jump of performance in all parameter counts. We have to exceed a certain number of parameters, and then this jump in the performance of the model emerges. And one final method that takes advantage of the context is the tree of thought method that allows the model to, in essence, split its context into multiple pathways so that, in essence, it can maintain multiple intermediate reasoning paths and explore each one of them separately. Now, there have been various theories that have been proposed regarding the emergence of in-context learning. Here I include two of the most prominent theories. Let us focus on the first one only. So according to the first theory, in context learning happens because during pre-training, the model sees many sequences where later tokens depend on some shared hidden structure. And in essence, the model learns how to exploit such hidden structures. So the claim is that during inference, the model treats the prompt examples as observations generated by some latent data generating structure. It estimates the hidden rule from the examples it's provided and uses it to predict the next case. So this is one, perhaps the most prominent theory in regard to why in-context learning, which is a particular emerging ability, emerges. So given this first theory, one way to interpret in-context learning is to treat the model's hidden states as, in essence, managing to encode an internal representation of the latent data-generating structure that lies behind the prompt examples. Furthermore, recently, it has been shown that, and this is taken from a paper that was published in 2025, it has been shown that through in-context learning, LLMs can, further than all of this we've mentioned thus far, can reorganize pre-trained concept representations in order to reflect alternative semantics. So here, for example, the authors have arranged a set of concepts into a circular formation, and they randomly pick pairs of neighbors, they randomly pick neighbors from this circle and supply them to the model. And what they found is that within the model, within the embedding space of the model, as we move into later layers, and as we increase the context length, specific formations appear that, in some sense, mirror the data-generating structure they used. So we can see it here, for example, at context length 400, at layer 16, and at layer 26, that the model manages to represent within its embedding space. Of course, these are here projections of the embedding space into a two-dimensional space. It manages to effectively reflect the data-generating purpose within its embedding space. And furthermore, as size increases, it has also been found that models gain the ability not only to modify their semantic priors, but to completely override them. So, for example, here we have a particular case of in-context learning, where a model is supplied with sentences and sentiment labels, and it has to predict the sentiment expressed by a particular sentence. So the authors found that we can, for example, flip the labels, or we can use nonsensical words as labels. And large models manage to override their semantic priors and correctly predict the flipped label. This is important because, as they note here in the bottom of the slide, this means that the ability to override semantic priors with input label mappings emerges with model scale, which should not be taken for granted because larger models presumably have stronger priors. So, contrary to what one would expect, larger models are better at overriding their semantic priors. Now, in regard to the structures behind in-context learning, so researchers at Anthropic have argued that in-context learning appears in larger models during a specific phase change that appears during the training of the model. So at this point, sufficiently deep transformer models have been found to develop what they call induction heads. These are attention-based circuits that support abstract pattern completion. So a simple induction head, for example, could work by finding a previous occurrence of the current token and then predict the token that followed it previously. Of course, this is a simple example. What they found is that at a specific case during training, transformer models tend to create almost all of their induction heads at the same time. And this appears as a sudden improvement in the model's ability to do in-context learning, appearing in a particular stage during training. Note that this improvement appears only in in transformer models that are at least 2 layers deep. The model which is only 1 layer deep appears to not be able to form induction layers, so its ability to do in-context learning remains minimal. And finally, before I move to one last emergent phenomenon, there is also some evidence that in-context learning, in essence, leads to the formation of conceptual subspaces by the model. Now, this is a paper that is also very recent. It was published in 2026. And as the authors note, as the model processes the prompt across layers, it integrates contextual cues to construct a shared conceptual subspace that emerges in the middle to late layers. Hidden states can be projected into this subspace, where the relational structure among representations persists across layers and across different demonstration contexts. Furthermore, they found that through causal interventions, that this subspace and its eternal relational structure are functionally involved in inference, and more specifically in in-context inference. So what they found is, in essence, that the model during in-context learning forms a particular subspace into its embedding space, and uses this conceptual subspace in order to do inference in context. And one final phenomenon I would like to mention is the phenomenon of grokking. So apart from emergence through scaling, it has also been found that even a single model of a set number of parameters may encounter qualitative phase transitions simply by training it for longer on the same data. This was found in 2021 by researchers at OpenAI, and the phenomenon, which they call grokking, I don't know why, is a phenomenon that appears not only in transformer architectures, but in all neural networks. So more specifically, what they observed is that in some settings, neural networks could exhibit substantial improvements in their ability to generalize long after they had already overfit the training data. Now, this is especially puzzling. So here is an example where we see the accuracy curves on the train set and the validation set of the model as we train it for further. And we see that as we train the model, it quickly reaches 100% on its accuracy on its training set. So at this stage, the model has in effect seen all the cases present in the training set and has managed to memorize the training set. Notice that at 1,000 steps, for example, its training accuracy is at 100%, but its validation accuracy, validation is a portion of the dataset they use where the model doesn't update their parameters, its parameters there. So they use it in order to check, to test its generalizing abilities. So at 1,000 steps, its validation accuracy is close to 0, but its training accuracy is at 100%. So at this step, the model has completely overfit the data. It has memorized the training dataset, but is completely incapable of generalizing to data outside its training set. However, what they found is that on this specific task, which was modular division, all they had to do was to insist on training the model, and suddenly the validation curve would start to get higher. So after a few steps, the model suddenly, for some reason, gains the ability to generalize. And if they insist on training, both the training accuracy of the model and the validation accuracy of the model reach close to 100%.
Vakil, can I ask something about the previous slide? So the validation, is it represented there? It's the green, okay.
It's the green, yes.
Okay.
So the model reaches 100% on the training set, but it's still at 0% of the validation set. This is a model that has completely overfit the data. All it has done is it has memorized the training set, but it has zero ability to generalize. I mean, if we present it with data outside its training set, its accuracy is close to 0. But all we have to do is to keep on training it, and the validation accuracy will, after a while, will jump and will reach 100% as well. Now, this is very unusual when seen from the perspective of traditional statistical and machine learning methods, where the dictum is, do not overfit the data, since overfitting the data is going to significantly impair the model's ability to generalize to unseen instances. So in most cases, in traditional statistics and machine learning, a model that has reached 100% accuracy on the training data, especially when its validation accuracy is lower, is treated as a model that has simply memorized the training set, a model that can't generalize. So given a choice, a somewhat simpler model that reaches lower training accuracy, but has smaller gap between its training accuracy and its validation accuracy, is to be preferred, as it will in most cases generalize better. Okay, here a visualization of the bias variance trade-off. To the right we have overfitting, to the left we have underfitting, and so on. On the other hand, in contradistinction to statistical and traditional machine learning methods, in some cases, neural networks that have completely overfit the data suddenly start to generalize better. In machine learning, a model that has 100% training accuracy, but 0% validation accuracy, let's say, is to be thrown out. There's simply nothing else to do. This is a model that will not perform well on new data. Neural networks, however, manage to, even if they have overfit the data, manage to raise their validation accuracy as well to 100%. And all we have to do is simply to insist on training them. Of course, I should note that this doesn't happen in all data sets. It happens in data sets that are characterized by a strong latent structure behind the data we feed to the model. So various theories have been again proposed here. In their paper regarding grokking, this is the most influential paper in regard to theories of grokking. Varma et al. Argue that it arises through a competition between internal circuits of the model. So they claim that that neural network models, when trained, form both a memorizing circuit and a generalizing circuit. The memorizing circuit fits the training set quickly, gives high training accuracy, but does not capture the rule that underlies the data. Therefore, even though training accuracy increases, test accuracy remains low. On the other hand, they also form a generalizing circuit, a circuit which in essence progressively isolates and learns the underlying rule behind the data, and which gives high accuracies in both the train and test sets. However, this circuit is slower to form. On the other hand, it is more efficient given the loss functions we apply when training these models, it turns out that the generalizing circuits are favored by the loss functions, especially when we apply methods like weight decay. So effectively, if we keep on training the model, gradually the generalizing circuit is favored and eventually overtakes the memorizing one. And finally, in regard to grokking, a prominent researcher in interpretability, Neil Nanda, and some of his collaborators, in their paper Progress Measures for Grokking via Mechanistic Interpretability, study a particular case where transformer models exhibit grokking, modular addition. The graph I showed earlier is taken from this paper. Now, by reverse engineering the weights of these models, what they found is that the models eventually learn to perform the task by mapping the inputs onto a circle and performing addition. So in essence, they have managed to verify that behind grokking lies an ability of the models to encode the hidden structure behind the data they are being trained on. And let me close by mentioning some things from the debate over understanding in AI. So with the recent rise of LLMs, a heated debate has also arisen in the AI community regarding the question on whether machines can now be said to have some form of understanding. This particular quote here is focused on understanding of natural language. As they write, until quite recently, there was a general agreement in the AI community about machine understanding. While AI systems exhibit seemingly intelligent behavior in many specific tasks, they do not understand the data they process in the way humans do. However, over the last several years, a new kind of AI system has soared in popularity and influence, one that has changed the views of some people about the prospects of machines that understand language. One faction argues that these networks truly understand language and can perform reasoning in a general way. Those on the other side of this debate argue that large pre-trained models, such as GPT-3 or Lambda, however fluent, cannot possess understanding because they have no experience or mental models of the world. Their training in predicting words has taught them the form of the language, but not the meaning. Now, what I wish to suggest is that given these results on emergent abilities, like in context learning, grokking, and their connection to hidden latent structures in the embedding space of these models, some form of understanding, some variant, some proxy of understanding could plausibly be attributed to such models. Of course, this is an area where you know much more than me. But in recent years, there has been a general debate in modern epistemology regarding the nature of understanding. So Christoph Kell, in his article Understanding Phenomena, helps us navigate the field by distinguishing between two broad camps. On the one side, we have explanationists who claim that understanding, in essence, involves knowledge of correct explanations. On the other hand, we have manipulationists, according to whom understanding involves a specific kind of ability on the part of the cognitive agent, roughly an ability to perform certain kinds of manipulations of certain kinds of representations of the phenomena understood. Now, it seems to me, even though I don't know much in this particular field, that certain of these empirical results from the emergent abilities and the emergent structures of LLMs can somewhat be adapted to the manipulationist view. So given all this progress regarding the internal representations of models, one could wonder whether some analog of manipulationist understanding could plausibly be attributed to them. As Wittgenfeld writes, a known manipulationist in his article, Understanding as Compression, understanding amounts to having a representational kernel and the ability to use it to generate the information one needs regarding the target phenomenon. Now, certainly, some of the examples we examined, for example, in the case of modular addition, the model seems to be doing something very close to that. It has some sort of internal structure that mirrors the data generating structure, and it uses this to generate its answers. So even if we can't, as of yet, really claim that these models possess understanding, empirically, maybe they exhibit some close analog of it. In his earlier article, Understanding as Representation Manipulability, Wittgenfeld develops a well-known definition in regard to understanding as manipulability. And according to his definition, a statement attributed in context C that thinker T understands object O, so he's concerned with understanding of objects, a quite general version of understanding, is true if and only if T possesses a mental representation R of O, so he speaks of mental representations. So it is not really clear to me whether we can attribute mental representations to today's AI models. So T possesses a mental representation R of O that T could, in counterfactual salient in C, modify in small ways to produce accented R, where accented R is a representation of O, and possession of accented R enables efficacious, according to standards relevant in C, inferences pertaining to R manipulations of O. So this is a well-known manipulationist definition of understanding. Now, I can't help but wonder, let us grant that an AI model exhibits an analog of understanding when it internally represents the phenomenon's latent structure in a form that it manipulates for context-relevant inference and actions. This is something that empirically, it seems that it has been found that modern models manage to perform in various cases. So an analog concept, which seems to me to reflect the thinking of many prominent AI researchers, could be the following. An AI model exhibits a proxy of understanding of a phenomenon O in context C, if and only if M possesses an internal representation R of the latent data-generating structure of O, such that R can be computationally manipulated in context-relevant ways to support inferences, predictions, or reconstructions concerning the phenomenon O. This seems to me could be used as a proxy of understanding for these models. And by closing, let me mention that it seems to me to reflect many comments done by prominent researchers in the field of AI. Here I have a quote from Satskiver, where he says, because if you think about it, what does it mean to predict the next token well enough? It's actually a much deeper question than it seems. Predicting the next token well, means that you understand the underlying reality that led to the creation of that token. Okay, so that's it from me.
I wonder whether I should start with clarificatory questions or just want to go deep into the philosophy.
My
Why do you
philosophy, my
think-
philosophy,
Why do
my
you think-
philosophical portion is not deep.
You said some intriguing stuff in
It's
there,
absolutely-
but
It's just a suggestion, nothing more.
Well,
it's a good enough. Okay,
I
let's
definitely have a clarificatory question I would love to get.
go.
If you could explain what that means right there on that, what's the thought behind that quote? 'Cause I don't
Shall we
understand.
start with genuinely clarificatory questions?
What it means is that
Maybe I can just focus. The part about the last part,
Underlying reality.
predicting the next token well means that you understand the underlying
now
reality that led to the
Now here-
creation of
yeah.
that token. That's what I don't understand what it meant.
Now,
Yeah.
of course, here he is not speaking particularly only of AI models. He speaks in general. Whatever does this, whatever manages to predict, whatever it is, humans, animals, models, anything, whatever manages to predict the next token well, means that it understands some underlying reality that generates the data it is being fed with.
I see, okay, that clarifies it. He's talking about in general. That's
Yeah,
what-
he's not
okay.
saying that this is not only about AI models. It's in general. Whatever. So if we can make AI models that manage to predict the next token almost at human-like levels or even at superhuman levels, maybe we should start thinking that there is some sort of
I see,
yeah,
okay,
it's
thank
just
you. Yeah.
So in the case of a model, reality would perhaps be the underlying rule
Yes,
behind the
yes. For
data
example-
set.
Yeah, for example, in the examples where the researchers find let me see if they have.
The grokking seemed to be the most interesting thing.
Yeah, in essence, they found that the model internally represents, in case of modular addition, represents the numbers it is being fed on within its embedding space. Of course, the embedding space is very high dimensional, so they have to project it into lower dimensions. And they find that, in essence, the model represents the structure of modular addition within its embedding space. It puts the embeddings corresponding to the numbers in a circular formation and then performs addition on that circle, mirroring exactly the structure that lies behind the data that they fed it with.
So it kind of understands what's supposed to be
Yeah,
doing.
so it seems to me that in this way the model has managed to isolate and represent a hidden structure that lies behind the data they feed it with.
You had a clarification?
Yeah, it sounds like Wittgenstein and rule following, like tricky, doesn't it? Like, you know what I'm talking about? There's a kind of, I mean, Wittgenstein has these examples of pattern, what are you gonna do next? Well, you don't know what you're gonna do next unless you have some understanding of the rule, right? You can't continue the sequence until you know what the rule is. I mean, crypty, I guess, takes it in a skeptical direction, but yeah.
Thoughts? He recently gave a presentation. about
Yeah, I guess so,
Wittgenstein.
but I don't know if Wittgenstein would accept the whole hidden structure component of all this. So I'm not sure.
Yeah, I don't think you would, well, if you mean by rule, it's just a rule, right?
Okay, so
The hidden structure is a pattern.
so it just manages to isolate the rule behind the language game it is being.
Yeah. I think that's.
This is plausible, yeah.
Yeah, okay. Mon,
Yeah, thanks. I'm gonna talk about grokking. So I'm as much a grokking optimist as you're gonna find in this room, I suspect. And for a good paper on grokking and understanding in epistemology, there's a recent paper in Field Studies that we just published. Remind me the name of the guy who does conceptual engineering in Switzerland. Yeah, Matthew Kellos.
Okay.
Ask me after your talk. So that's a paper from an epistemologist that knows about grokking as well. So it's informative because that man actually knows about epistemology. It's not computer scientist, but also works with computer science. So a couple of things. So there's conceptual competence and then there's conceptual understanding. And those are not the same things, right? So conceptual competence, the easy way to think about it is that is the lower threshold of conceptual understanding. Right, so I can be minimally conceptually competent, while nevertheless not meeting any reasonable threshold of any context for understanding the attribution.
Yeah,
right, so I can just basically, have a disposition to apply the concept well, but if you are to ask me what's a duck, I have no idea what it is, right? So the move from, so I am a big optimist that grokking is a machine form of conceptual competence because of this generalization tendency. So I ignore that on grokking. That's why I said that I'm as big an optimist as you're going to find in this room, I suspect. But that from there to move into linguistic understanding is a huge step because linguistic understanding.
There were some intermediate steps.
There's a huge step that was not argued for, is what I'm saying.
The intermediate step was this one here, that in a particular in this paper where Neil Nanda, sorry, I don't know how to pronounce his name, Neil Nanda. So the intermediate steps were two actually. One is
it generalizes and then it cleans up. I know.
One is this. The other is that the result by Nanda et al. That in modular addition, in essence, they managed to reverse engineer the weights of this model and found an internal representation of the structure they used to generate the data within the embedding space of the model.
Okay, so maybe I'm not making myself clear. So applying, being able to generalize from particulars to the general is a promising way to think about machine conceptual competence. If you are an optimist like I am, and if you're not, like John, you're probably getting very annoyed right now. But from there to conceptual competence, so my daughter, when she was 3, she was conceptually competent with the concept of yesterday. She was applying it quite reliably, right? But if you ask her what exactly does it stand for, she would not be able to explain, she would not be able to tell you what the relation between yesterday and a year ago is.
You move into an explanationist.
No, that is just what linguistic understanding is. The more you know about the concept, the more your linguistic understanding increases.
Yeah, but
Just a second, can I finish my question? Just let me finish my question. So there's conceptual competence, using it well in conversation. Let's talk about children, maybe it's easier. And then there's conceptual understanding, which comes in degrees. It can be maximal, and then it can be appropriate for the context of attribution. And then I have seen no argument that for a general context of attribution, that grokking amounts to linguistic understanding. All I've seen is arguments that with a bit of optimism, it might amount to conceptual competence. But what I found even more interesting is that they also, on a later slide, very quickly move from linguistic understanding to understanding of the world. And that's a different thing. So language is just a phenomenon. I can understand English language without understanding physics. Indeed, it is my sort of situation. So how do we move there, I'm wondering? So what's up with that?
In essence, I don't really claim that these models, because of grokking and so on, do possess understanding or something.
Oh, it was a slide just a bit earlier, maybe the slide before?
Something close to it.
No, it was literally this, not close. Here, I think, yeah. to understand natural language and thus understand the physical and social situations that language can describe. The
This
thus.
is just a quote from.
Well, I know, but why is it on your side? Did you endorse it? Because some of these
No,
quotes-
I do not.
Yeah.
This is just a quote I included because it seems to me that this paper describes well the overall situation regarding the debate over understanding in AI, and it presents it from the computer science camp. So this is not a philosophical paper. Melanie Mitchell is a computer scientist and wrote this expository paper. So this is just a quote to mention that this is a very heated debate, a current debate in computer science as well.
I mean, I understand that there is a debate in computer science, but I guess we're all debating about the same thing, the truth. Do these creatures have linguistic competence? Yes or no? Do they have linguistic understanding? Yes or no? Do they have understanding of the world? Yes or no? And what I'm seeing here is just grokking might look like conceptual competence, but all of the other stuff is mind-boggling. And I'm wondering, why do we include it if it's false? I mean, if I included a slide that said, AIs can dance with me at balls, you'd have been surprised.
Let me try and pacify the situation.
I'm not fighting, I'm
just to say the way
I was getting upset.
just to say how I heard.
This is getting so upset. I don't know what the other folks are gonna do.
Just to say, like the way I heard Vangelium's presentations. Look, here are some data, here are some phenomena. Here are some people saying that there is understanding. Here are some conceptions of understanding, including Christie's.
But that's not the understanding of the world, right? So,
No.
We are confusing between linguistic understanding and understanding of the rise of the Roman Empire.
I am the chair, you must stop interrupting.
Oh, well.
So I'm just saying, like, let's try, because I think he was giving us some intriguing information, and then we have to figure out, if, well, they don't understand, or if they understand, do they understand in some way? In what sense? How do they fall short? So, yes, all your points, like, very super duper useful, not to bring down what the slides say, but to try and figure out what's the difference between what it does and what we do.
But isn't that the responsibility of the speaker to make the claim? So, is the claim that what these people are saying is true?
It's exploratory.
No,
it's exploratory.
Because it's false, is all I'm saying.
I'm not saying that it's true or false. I'm just saying that given this evidence for internal structures, maybe some manipulationist proxy of understanding.
Understanding what? Language or the world? Because that's a confusion.
But this is what we're trying to figure
of
out.
Objects, of a general understanding. So my only suggestion was that maybe some proxy of manipulationist understanding could apply here, nothing more. So maybe my claim is very weak, but it is based on all of this empirical evidence on internal representations of these models that to me suggests that these models, particularly when you contradict them to traditional statistical and machine learning methods, manage to, in many cases, internally represent some form of latent structure. Now, maybe this isn't what we say understanding, but still, it is a new paradigm, especially when comparing it with earlier methods. So maybe it is some sort of proxy of understanding, and maybe later models will expand this and develop it into something closer to what we understand as understanding in philosophy today. So let's say.
So can you answer my question? Because you said that your claim was that some of the structures suggest that these models perhaps have a proxy of understanding. And I said, well, some of what I've seen so far only suggests that they have conceptual competence, not linguistic understanding and not understanding of the world. So can you answer that question?
In my view, if the model manages to, I mean, you might present it with data that in its surface has, I mean that you may use some structure to generate data that don't carry the data generating structure on the surface, and then feed this data to the model until it reaches 100% in validation accuracy and so on. If you then discover that within its representations, it has managed to move beyond the data, beyond the surface data, and has managed to codify the structure you used to generate this data, then in my opinion, yes, it has some sort of proxy of understanding, not just competence.
Or understanding what?
Of,
Let me just let's work, because he's
For
not an
example-
epistemologist. Let's work with him rather than trying to, because that's the thing. Like he doesn't know as much as we do about understanding.
I made it-
Understanding what? That's what I'm very calm. I'm trying to ask to figure out what is claimed. You say, in your opinion, it has some.
For example, in the case of modular addition, since it does modular addition by representing the numbers in circles and doing the operations on these circles, my claim is that it has a proxy of understanding regarding modular addition. It understands modular addition.
I would like to hear Chris's view as well later. Yes, Adam, please.
Yeah, this is just I guess it's a kind of follow-up. It's about, this is meant to be constructive about appealing to manipulationism at the end. So here's I don't know, a point from the epistemology of understanding that might help make that position more plausible. And it also connects with some of what Mona was saying about being clear about understanding what. So one thing in the philosophy of science and understanding literature there, and at the intersection of epistemology, was that, right, you can understand, setting aside understanding language, you can understand a theory, right, where we treat a theory as an object. So I might really understand phlogiston theory really well because I went to a science class and I learned how the theory works. And I also might know that it's a rubbish theory, right, because it doesn't help me. It's not true to the phenomenon of combustion, as we now know, right? So if you look at the manipulationist claim, and this is one reason why Wilkenfield, I think, gets it wrong from an epistemology point of view. He just requires, I mean, trimming through the fat of the definition, look, there's a representation component, and then there's a manipulation component. And a problem with the representation component for Wilkenfeld is that it just requires a representation. And that's too cheap when it comes to understanding phenomena. And the reason is, if you go back to combustion, right, I don't count as, I don't count as understanding of phenomena, in the world, right? If my representation, it doesn't involve something like affirmation, and even beyond that, something like maybe a true belief or knowledge or justified belief. So things like justification and knowledge start to enter the picture on the representation part. And my main point in a nutshell is that if you don't put that in, then you end up with something that can't make sense of how you understand a phenomena as opposed to just understanding a theory, which is something an epistemologist should want to care about. Or not just an epistemologist, but we want to care about insofar as we want to give an account of what it is to understand things in the world, right?
No, thank you. I agree with your comments. I know of the problems of Wilkenfeld's definitions. So, yeah, thank you.
Put a little epistemic conditions in there.
Yes, sir.
This is just purely just nice of you to say more about large reasoning models. What kind of reads are just not clear. Because sometimes when I read papers, they really struggle with critical reasoning skills, so they don't follow explicit procedures. They overthink limiting premises and so on. So they do reasonably well when they're doing deductive reasoning and so on, but like adductive reasoning or any kind of type of ambiguous reasoning, which is get more out of more content out than you have in the premises. They really struggle with that. Can you say more about, in your view, where do you think the strength, or what are they not very good at the moment, these reasoning models? I'm very interested in that. Just purely like, it's not criticism, it's just inviting you to say more about them.
Okay, so this depends on the methods you apply when you are trying to incorporate context into the inferential processes of the model. There are various methods. For example, here to the right is a visualization of the tree of thought method, where the model, for example, at each step breaks up its context window into multiple branches and explores each one of them separately. Now, one difficult part of this method, so many of the current reasoning models follow this method, or at least one part of them is this method. But there are also problems that arise at the level of how, okay, so the model explores all these reasoning paths, but at some step it has to somehow gather all of this reasoning it made, and in order to produce a final answer. And I think, from what I've read, that in many cases, many of the issues these architectures face with specific examples of reasoning problems stem from this problem of how to aggregate the different inferential paths it has explored into one final answer. So I think that most of the problems are focused there.
This is interesting. Every time you read about a famous case of it reasons incorrectly. Like when you ask them whether isn't 9.11 smaller than 9.9, no, 11 is larger than 9, but it just gets it wrong because just, again, that's the older model where they're just big and talking, but now they have this, Adam talked about yesterday as well, this reasoning kind of module.
In essence,
so they're not really doing that anymore. They're not just like consulting the data to see what's most likely to happen now. They are
in essence, what they do is that they incorporate the context window into the model is either trained or prompted or adapted to produce intermediate tokens and put them into its context window. So as it generates the next tokens, each token, in essence, attends to the previous ones, absorbs information, and the model can use this information in order to infer better. But in certain methods, there is a problem on how to aggregate, especially when, that is what I claimed earlier, that, okay, we may incorporate its context in order to produce better reasoning, but in cases where the models explore many different reasoning paths at the same time, there is a problem on how to aggregate all the paths. There they use various methods, but in many cases, the later reasoning models fail at this step.
John.
Yeah, thank you so much. The first part of the paper on the computer science, I got very little from that because I just don't have the resources. But I love what you're saying about understanding, and I thought that you kept using the word analog. We have an analog of understanding. We have a proxy for understanding. I think that's very, very important. So I'm thinking about so from my point of view, as the AI gets better and better and better at what it's doing, it's not going to go from an analog to the real thing. It's going to just go to better and better analogs, right? And it has part of the reason is because of what Adam was saying. What it's really getting really good at is manipulating representations and detecting patterns in the representations and in the data that's being represented. And that's all an analog of understanding the world. I think you're absolutely right that the manipulative concept of understanding is really like a nice one to use in that respect. But I also think that there are analogs that could be explored with other conceptions of understanding as well, including explanations one, right? So anyway, I just wanted to say that I think that's really nice. I mean, I'm thinking of writing a paper on this idea of the analogical use of a lot of different terminology that we use to apply to the AI. I think it's absolutely apt, and that's why it's just so natural to talk in this way. So I would, I think you've given me like another example of maybe the usefulness of thinking about that analogical approach.
Yeah, I mean, after all, these are artificial systems. For sure, we haven't reached AGI or something, so we can't really expect them to really have understanding. But maybe some analog concept could be useful here. For example, as a standard, as a measure of progress. I mean, these models do get better and better at something. Maybe they get better at internally representing latent structures in the data. What is the epistemological concept that corresponds to this?
I'm going to try an analogy and let me know whether it's close enough. I mean, it's going to be contentious, but I just wonder whether it might be a similar situation to what happens to some humans, for instance, within science. So you said that, I think it was towards the final slide, that perhaps the reason why this is just manipulationist understanding is because they don't really have contact with reality and they cannot really grasp what it is that they're talking about. So that made me think of, for instance, how physicists might, and that's a contentious bit now, understand the world of subatomic particles, which we have never directly observed. We only have a theoretical understanding of them and indirect observations of them. But still, I mean, the best physicists, they seem that at least they understand what the theory about subatomic particles says. They have a grasp of what it is that complex mathematical theory is supposed to represent. Would that be a similar situation, or would it have like significant disanalogies?
Okay, with the case of a physicist, okay, let's say we have a physicist that doesn't have direct phenomenal contact with subatomic particles, but somehow manages to extract a theory of a subatomic theory of physics. Now, if these physicists, through exposing himself to the data obtained through various experiments, in essence manages to mentally codify a particular structure and then puts out this structure in a linguistic form, it would seem to me that this is an analogous situation. But this is just, this is not something I say with conviction. It's just something that it seems to me to be similar. After all, we really can't say anything with conviction about these models. And perhaps some of the components these models use will also be used by models 10 years from now, but along with other sort of components. So the situation is very fluid. Yeah, so.
Okay, well, let's thank Vangelis for the have half an hour break or more? No, half an hour break until Duncan, so it's just gonna be online.
Oh, so I heard go from Landor, give a couple of talks and review. I don't remember the name of the book, but I'm assuming that was like policy.
Yeah.
Don't you remember what kind of about policy or anyhow, it's in the.
The author, yeah.
Yeah, it's just like most pieces of that I just find.
Carrie Fisher.
Just a second. I asked something.
She is talking about, she talks about, she talks about.
It is not excuse it out for private health and what the truth is. It's okay to get things that are small, it's the same as the business. And the best industry in the world, then you keep apologizing. You can't stand to office, there are some important messages that it's not yeah, see, let's start the fucking let's not have any time.
Actually, I.
Oh, I could just take, I could just do it.
I probably know your phone. Yes. Oh, I do not have it. Sure. It's not on my phone for some reason.
I can just take a picture.
I know, yeah, that's really nice. It's good.
No.
I'll call you right now, or I'll text you right now. Give me your number.
Mona, do you know this book by Carrie Fisher? Pieces of Mind? She's talking about the use of folk psychology in biology, like to amoebas and she talks about, yeah, she talks about the analogy, the analog approach, I'm pretty sure. I can't remember whether she adopts it or misses it. It's pretty fun book.
Yeah, I've got you, so I'll just text you. Thanks, I appreciate it.
So John, I'm struggling to find your email because I've changed my email from Glasgow to
Oh, yeah,
Oxford
okay,
and I'm not
I'll,
in my contacts.
I'll just, I've got your Oxford address, I'll just email you and then you'll have my email.
But I sent you something
Yeah,
really.
you have, but I know I have your Oxford address.
I'm actually sending you the review of the book, so I'll give you.
Okay, great.
Do you know if Carrie is still in Edinburgh usually, or is she back in the US?
I don't know.
Oh, you sent me your, paper, using your Oxford, your Glasgow address.
I am, yeah, because it's easier to send you stuff from there because I have your contact.
Right.
I found it again, I'll send this one.
Okay, thank you. Appreciate it.
Everything goes? Okay. Ναι. Μπορεί εξίστη, τα άλλα, γιατί δεν είναι σίγουρο. Καταλαβαίνεις.
It's called Pieces of Mind. I think I'm gonna miss Duncan's paper. I'm gonna say goodbye. My mother is in the hospital, so I'm gonna go home. She went in last night, but we had to coordinate all of my siblings. What is that? Well, it's great to see you again.
Great to see you as well,
Yeah,
see you
thanks
next
so much.
time.
It's just been fantastic.
Αυτό είναι απλά επειδή ξέρεις, στο τελευταίο δεν ήθελα να πω,
Yes,
επειδή ήξερα
yeah,
ότι
yeah.
θα κλείψω στο κοινό.
Yeah, that would be great.
Δεν ήθελα παρόλο στο που είναι 100%. Οπότε,
Yeah.
τα πάμε.
Thank you so much.
Ναι, γιατί. Τέλος πάντων. Ναι, κάπως έτσι. Εντάξει. Το υπόλοιπο κομμάτι πώς σου φάνηκε? Ευχαριστώ, ωραία. Το ξέρω, μάλλον. Αλλά επίτηδες το είχα κάνει αυτό, γιατί δεν ήθελα να πολύ... Ήθελα να το κάνω πιο ήπιο. Εσύ μου λες κακός. Εντάξει. Ναι. Εντάξει, σίγουρα δεν έχει και τόσο. Σίγουρα δεν έχει. Ναι, δηλαδή, εξής αυτό το κομμάτι, ας πούμε, μου φάνηκε και εμένα πολύ πράξενο, δηλαδή ότι δεν είναι competence και δεν understanding. Και δεν κατάλαβα γιατί ήταν τόσο σίγουροι. Οκ. Έτσι να τους πω. Τους βάλω αυτό να κάνουν και βλέπουν ότι μέσα αυτό που κάνει είναι ότι το πετάει σε έναν κύκλο και κάνει την πρόσθεση. Δεν έχει καταλάβει. Ναι, δεν έχει. Δηλαδή ο κύκλος. Ναι, είναι μεταεμπέδειξη. Ο κύκλος δεν είναι στην επιφάνεια. Και αυτό το βρίσκει από πίσω και το κάνει. Αυτό δεν είναι. Ναι, ακριβώς. Τώρα με συγχωρείτε, δεν είναι αυτό. Δεν έχει καταλάβει και πρέπει να κάνει πρόσταση. Δηλαδή, πες εσύ ότι είσαι να εξελίσσεις τον μαθητή και του δίνεις παραδείγματα και σου λέει «Α, κατάλαβα, θα κάνω την πρόσταση με αυτόν τον τρόπο». Δεν θα πεις «Μπράβο, το κατάλαβα». Τι θα πεις, όχι, ότι έχεις competence. Ακριβώς. Ναι, ακριβώς. Απλά, τέλος πάντων, έχεις δίκιο. Απλά εγώ επίτηδες το φοβήθηκα και τον έρωσα για να μην με φάνε τελείως, ας πούμε. Εντάξει, δεν πειράζει. Έπρεπε να έχεις έρθει, να έχω λίγο...
But I think in order to make sense of that, we have to step back and think about the overarching epistemic goals of education. Just some qualifications. I'm just going to focus on what's called second wave generative AI, the DLMs that are currently very popular. I'm sure you're aware this usually gets split into three waves: predictive, generative, and the new wave, which is either here or it's coming, depending on who you talk to, the agentic AI. And also, I'm going to talk, when I talk about education, my focus is actually higher education. But I don't need to get into that. Most of what I say would apply to it. I mean, there are some things I say that maybe only apply to higher education, so best to focus on that, and that is kind of primary interest anyway. Although a lot of what I say, I think, would apply to education more generally. I also want to set aside there are a lot of interesting philosophical problems, it seems to me, from an epistemic point of view, about not just generative AI, but the whole three waves, actually. But I'm going to focus on, let's mention what they are, though. I mean, I think they're worth mentioning because I think once you understand the nature of the problems, I don't think they're going to be solved by the move to agentic AI, which is what a lot of people think, because I think they're built into the very nature of how we're doing AI. For those of you who follow these things, I'm very much with the sort of Chomsky line on AI. I think that a wrong turn was taken at a certain point. And I think because of that, there are some structural limitations in AI, how it's working at the moment, which I don't think you'll be overcome just by simply letting it evolve in the way that it is. But in any case, the problems I guess you'll probably be familiar with, I mean, the fact that AI lacks understanding, thought, reasoning, it's just a sophisticated machine. I mean, some people dispute this, but I think, I mean, increasingly, it seems hardly a day goes by without a new study coming out which confirms this. I say here no concern for the truth. I mean, again, this is the sort of Chomsky like where these things are trained on this large data sets concerned with our behaviors. But our behaviors, as it were, are trained on the world. Just like our language, they're created in a sort of in terms of a triangulation of persons within a shared world. So they're already linked up, as it were, to the truth. And in fact, I think actually it's part of who we are as human beings since behavioral modernity, anyway. For us to have this concern for the truth, the AI doesn't have anything like that. And I think this creates problems for it. Relatedly, I think the kind of mistakes it makes, mistake actually, interestingly, probably isn't the right word. The kind of errors it makes mean that it isn't a reliable source of information. So I'll qualify that. It's not a trustworthy source of information. I actually think it is a reliable source of information, at least in one sense of reliability, a sort of statistical sense of reliability. It's not trustworthy, though, I think, because it's unsafe. I mean, the kind of hallucinations, as they're called, or confabulations that the AI makes, which I think relate to the fact that it isn't linked up to the truth properly, I think make it untrustworthy. And if that's so, it's not a route to knowledge. These are, I think, all interesting epistemological issues, but they're not the ones we're going to talk about today. I want to talk about this from an education point of view. So let's think about the overarching epistemic goals of education. Now, obviously, education serves many kinds of goals: social, political, practical, and so on. But the epistemic goals are fundamental, at least in the following sense. A social practice that didn't have positive epistemic goals couldn't be an educational practice. It might go by that name, but it couldn't actually be an educational practice. So if North Korea has some program of indoctrination going at the moment, it probably does, that wouldn't be an educational practice, even if that's what they call it. And that's because it's not serving positive epistemic goals. So I would suggest that epistemic goals are fundamental in that sense. And that raises the question of, what are they? How best to understand them? And there is a debate about this. I'm going to simplify the debate and just consider two extremes. One extreme, which I think is actually still very popular in the sort of general public, sort of popular imagination about what education is about. And I think actually as educators we slip into it sometimes when we allow certain narratives to take hold, that we should evaluate education in terms of, outcomes like employability and things like that. It's a conception of education which is quite reductive. It's that education is just about giving people, from an epistemic point of view, useful knowledge and useful cognitive skills. Certainly this was a prevailing view of education until not that long ago, in sort of the history of ideas. I have in the picture here rote learning, a depiction of rote learning, which is very popular, certainly in the Victorian age. For those of you who don't know, rote learning, the student would learn, they're on their own with a book or something, they'd memorize some parts of that book, and then they'd be brought to the front of the class, and they had to regurgitate what they've learned. If they did it well, there was a reward. If they did it badly, there would be a penalty. Usually a penalty involving some kind of physical punishment. Rote learning, which by the way my parents did in the 30s, very effective. We don't do it anymore. I think obviously partly we don't do it for ethical reasons. We don't think we should be beating children. But I think even if you set aside the ethical concerns, I think there's epistemic concerns there. We have an idea that educators, that's not what education is about, even if it's effective at achieving those epistemic goals. And I think partly it's due to the fact that we think the epistemic goals are the wrong ones. We're not really about sort of drumming in information to people, what I call the bucket model of education, or something like Paulo Freire calls the bank model, where you sort of make deposits into the child, as it were, in terms of information, knowledge, skills. But if you did grant that that's what education is about, then I think it would seem as if the AI challenge is just one of degree rather than kind. Technology changes the way we do these practices to give the knowledge and skills. If personal calculators come along and it's not necessary to drill certain kinds of arithmetic into students anymore in the way my parents would have it drilled into them. Same with AI. AI is going to do lots of things that we currently do now in education, so we just let the AI do it and we find other things to do in education, to be different kinds of knowledge and skills. On this way of thinking about it, there isn't a fundamental difference between the challenge that AI poses and the challenge that technology in general poses. It's a lot of technological change happening very quickly. I think that's the wrong way to think about things. I think it's the wrong way to think about things. It's the wrong way to think about education. So I think there's a more plausible conception of the overarching epistemic goal of education, which is development of good intellectual character. I want to construe this in a broad sense. So there's lots of different conceptions of intellectual character. The two main ones actually in the literature, some of you I'm sure will be familiar with this. On the one hand, sort of critical reason type, which is people like Harvey Siegel, who's championed this. His PhD student advisor was Ralph Schaefer, did earlier work on this earlier on. And then there's the more demanding proposal, which you find is educated for intellectual virtue, which is with Jason Baer and myself. Heather Battle has written about this and others. I've got Aristotle there. Aristotle, of course, is representative of the second camp. We don't need to get into the differences, I think. I mean, as I say, my foot is squarely in the educate for intellectual virtues camp. I think we should educate for intellectual character in that specific sense. But it doesn't matter. What matters is that we're educated for a good intellectual character for the purposes of this paper. So we can have a family of views in play here. And what that means, if you think of it in the broad sense, is that we're educated for an integrated set of stable, domain-independent metacognitive skills that perform a managerial role in one's cognitive architecture. I'm going to call these the executive cognitive skills for short. Intellectual virtues are one subcategory of the executive cognitive skills, but they don't exhaust it. Certain, high-level critical thinking type skills, and character traits of a kind like, for example, one I'm going to keep coming back to is, to be observant, to be an observant person. That's very different from the sort of perceptual skills involved in seeing, but also very different from the quite specific observational capacities you might have to do very specific tasks. It's a very general character trait, stable character trait of the subject, which we find laudable of the subject from an intellectual point of view. Possibly admirable. The virtues are definitely admirable. Executive cognitive skills, they're impressive, let's say. They're not always admirable. And That's how you use them. But certainly they're representative of your character. And I think it's that good intellectual character that we want to educate for, not just the knowledge and skills. Of course, we do want to educate the knowledge and skills too. The point is, we do that as a means to cultivate the intellectual character. So why do this? Lots of reasons. I'm going to mention a couple. I'm trying to explain this, and I'm trying to defend a view in its broader sense. So I don't want to appeal to those considerations that I think are specific to intellectual virtues, for example, to do with our flourishing. So I don't want to do that, but I think there are more general considerations that apply even on a single type view. And it relates to what I would call a liberatory conception of education that gets articulated by like otherwise quite diverse figures in the sort of education field. I have here on the PowerPoint Wilhelm von Humboldt, who was involved in establishing the curriculum for the Prussian universities and very influential Germanic universities in Europe, Germanic-speaking Europe, universities in Europe. John Henry, so I mean, he's in the sort of mid-1800s. John Henry Newman, so maybe early 1800s actually. John Henry Newman is the mid-1800s in Britain and Ireland, very influential in education, particularly Ireland. Talking about the idea of the university. John Dewey later in America, in the 20th century. And I also mentioned Paulo Freire in Brazil, sort of mid-20th century, mid to late 20th century. They're very different figures if you know anything about them. You know, in that list there, you know, you've got like you're a Marxist liberation theorist, you've got a socialist, you've got a patrician, member of the gentry, and you've got someone who actually is not long ago got to be canonized and is now a saint in the Catholic Church. So a pretty diverse group of figures there. But what they share, it seems to me, is the liberatory conception of education. Education, like it's crucial, our understanding of it is in terms of responding to the universal dignity of persons, and where that has an intellectual aspect to it. We're not just, education isn't just about drilling in useful knowledge and skills. That's kind of in a way degrading, that's dehumanizing the individual. Rather, it's helping them to give them capacities of self-realization. So an intellectual freedom which enables them to self-realize. And that we preserve their dignity by doing that. So, you know, drilling in useful knowledge and skills, that doesn't do that dehumanizes them. We respect their dignity by enabling them to be self-learners and so forth, thinking themselves. And that requires cultivating intellectual character. Von Humboldt's very clear about it. Humboldt and Newman are interesting. Their focus is both on higher education. It's not a coincidence that these ideas about education first get their foothold in the sort of Romantic period, so late 1700s, early 1800s, where ideas about the dignity of persons and helping all persons to realize their potential become, you know, the forefront of history ideas. And it's also not a coincidence. These are ideas that get their footing, as it were, when we start to have establishment of public higher education. Right? And that's what von Humboldt was involved in, that's what Newman was involved in. Their focus is on higher education, Dewey and Freire more education in general. But you can see in the higher education context is very clear, you know, because we're dealing with adults. You know, the idea of just drumming in useful knowledge and skills to adults, you know, the idea that would be dehumanizing and not preserving their dignity, I think is quite powerful. In any case, I would suggest that education, when done well, that's exactly what it does. Educators, you know, they don't learn people. They're facilitators. They provide scaffolds. To use the sort of language that educators use when they describe good education practices. There's another good reason for educating for intellectual character. There's an empirical reason. One of the great things about being at UCI is that I got to work with empirical people, education, sociology, and elsewhere who work on education. And especially Richard Aaron, who's a really big name in education, done a lot of empirical work on educational outcomes and what kinds of things actually affect educational outcomes and what don't. And one of the things he's most famous for is this idea that, which is hugely supported by the empirical literature, that a lot of what we teach, including what we teach in higher education, is almost universally lost after a few years. Certainly, unless you're using it, in many cases you're not. You test people who, when they're in college, would perform really well on these tests. Test them 4 or 5 years later, boom, they're almost back to where they were before. In many cases, back to where they were before they took their degree. And that raises an interesting question as well. What is it we're actually doing? What is the point of college education if that's the case? And one thing that Aaron and his colleagues are interested in is this idea that education, because it helps cultivate intellectual character, and intellectual character is the stable long-term feature of the agent. This is something that survives. It's still there 5 years, 10 years, and so on. And now we can make sense of the point then of education. Maybe the specific domain relative skills and so on, they may atrophy, but the character, the intellectual character that is fostered, that remains, and that can explain now the value of what it is we're doing. I'm going to say a little bit about executive cognitive skills. As I say, my primary interest is in the intellectual virtues, which is a particular kind of executive cognitive skill. But let me see if I can say intellectual virtues have more specific properties than these. For example, intellectual virtues have motivational components, which are quite crucial to them. But I want to think of them, as I say, as these metacognitive skills. They direct one's domain-specific knowledge and cognitive skills, right? So they're a higher order. They're not innate. They're acquired. That's important. They are skills. They're not just factors or something like that. They have to be cultivated, or they'll degrade, just like any other cognitive skill. They're stable, they're long-standing, they manifest one's intellectual character. We assess you as intellectually as a person by appealing to these kinds of traits. They provide epistemic autonomy, active knowing, understanding. So they, as I said, they're helping you to think for yourself, helping you to be a self-directed inquirer. They form a managerial role in your cognitive architecture, and that kind of falls from the first point, I suppose, but it's worth emphasizing. When the managerial role is done well, it's done well because you have these executive cognitive skills. And I've actually been observed before, being intellectually conscientious might be another one. Certainly when we start talking about intellectual virtues, it's very clear that they fit into these categories. Okay, so now let's get back to technology use and how we might think about this in the educational sphere. So it's taken uncontroversial that whenever we integrate technology into cognitive practice, we produce these feedback loops that change that practice over time. I mentioned earlier, how my parents learned arithmetic, it's different to how I learned arithmetic. I want to focus on a particular example which might resonate with this audience, which is thinking about how academics do their philosophy, right? We'll focus on philosophers. You might recognize the person in the image here. When Dominic was in St Andrews in the 90s to the Gifford lectures, I remember speaking to him about how he wrote, and he told me something that I opened, which is that he wrote, this was still true when he said it changed afterwards, but he was saying that everything that he wrote was written on a typewriter, the old typewriters, the hammer typewriters. And he said he was just two versions. There's an initial version, she typed out, right? So from his thought to the typewriter, then that was annotated, and then on the place of that, a final version was typed out. And that was it. When you start to think about, especially when you factor in just how incredibly complicated Dominic sentences are. Dominic is notorious for the sentences that go on for whole paragraphs, that's so close. That's quite a remarkable feat. What that means is that an awful lot of, as it were, thinking and editing is going on in his head prior to the committing it to the typewriter, it seems to me. In general, one of the things, the evolution of writing is that, it used to be there's a lot of cost involved in revision. And so there's a lot of importance in getting it right, with getting as close to right as you can first time. Whereas gradually, when you have word processing softwares and personal computers and so on, that cost is pretty much gone. And so now we write differently. I mean, I'm sure I'm not alone in this, but, you know, I think as I write. In fact, for me, the thinking and the writing is inseparable. I work out what I think by typing it out and engaging with it, right? That's the idea of doing this offline. It seems to me like, and it is kind of pointless actually. Why do that? When you've got the typewriter, you can type it. There's no cost involved. You know? So there's these feedback loops which change the manner of one's fluid. As I'll get to in a moment, it doesn't seem to me that this is like a degradation, that we're degrading that thought. I mean, along one narrow axis, perhaps someone's degraded, maybe there's something impressive. Just as there's something impressive about my parents' generation being able to perform these songs very quickly in their head. In the grander scheme of things, it doesn't matter that much. You know, we're still doing the thinking and the reasoning and so forth when we do the writing, just doing it in a different way using the technology, an easier way. You know, the same when we do the arithmetic with the calculators. So the point now is just that there is this fundamental change. These feedback loops create a change. I think it's useful to think about what's going on here in terms of extended cognition. So one thing you see in popular science writing, so popular press, is this idea that technology makes us dumb. It's a recurring thing. It keeps coming back. Lots of people, including some pretty respected cognitive scientists that pursue this line. I think it's based on a confusion. Certainly, I think if we bring in extended cognition, we can show that it's at least too simplistic. So think about these feedback loops. The feedback loops come in as we start to integrate the technology into our practice. And for the sake of argument, I just want to take it as given for those of you who follow the extended cognition issue. Whatever is required for cognitive integration here, let's just imagine it's met. So obviously, not every use of technology is extended cognition. I'm not suggesting that. I don't believe that the other. But there's got to be some pretty robust conditions placed on when a technology is suitably integrated into practice for it to count as extended cognition. But certainly that happens. I think that happens with the word processing. You know, word processing has become integrated into practice. So now we write differently because there's an extended cognitive process going on, which wasn't there hitherto. So something has occurred. The feedback loops have changed the cognitive processes. You can see where people say technology is making it stuff. You can see where they're coming from because there's a word onboard, an exclusively onboard cognitive skill, which has become degraded. You know, I don't memorize as many telephone numbers as I used to because I don't need to have a mobile phone, right? I'm old enough to remember when there was like 20 plus telephone numbers in my memory. Like there's probably like 2 or 3 now. Maybe in the Delta case, maybe there's certain kinds of thinking offline which are difficult for me, but wouldn't be difficult for some adult generation. Maybe there's certain arithmetical tasks that were easier for early generations, harder for me. So there is a certain cost, but it seems to me the cost is more than outweighed by the enhanced cognitive powers that come from the extended cognitive process, right? So if we look at the subject, the extended cognitive subject as a whole, the cognitive powers have increased. There's been like a sort of trade-off, a degrading of an atrophy of certain onboard cognitive powers, but overall there's an expansion of the cognitive powers of the subject. And I think that's the sense in which normally technology doesn't make us dumber. In fact, it's quite the opposite. Technology enhances our cognitive powers, even if it leads to a slight degrading of our onboard, of some of our onboard cognitive powers. I don't think that's necessarily the case, but it often can. AI, though, I think now we can start to see why AI is so different to more technology use. Right? So normally, when we employ technology, it's like the calculator, or it's like the word processor, or it's like the phone, with the mobile phone, the smartphone with your telephone numbers. It's taking away quite a specific domain-specific skill or domain-specific knowledge, and it's offloading it onto the technology. And it's embedding it within the technology with a view to giving you, now I have access to more numbers. Now I can do more complex arithmetic. Now I can write more easily and write well and so on. But AI isn't like that. AI isn't just offloading these domain-specific skills. What it's doing is removing the need to do the kinds of things that develop executive cognitive skills, right? So the thing about the AI isn't that it's helping you to write essays better. It's that AI is writing the essays for you. It's not that AI is helping you to read better or facilitating reading. It's making it so you don't have to read at all. AI is making it so that you can summarize other people's ideas more effectively. It's doing the summary for you. So in each case, what we've got is a technology doing the very kinds of activities which would cultivate our executive cognitive skills. And that, it seems to me, is a fundamental challenge posed by AI. Why it's different from other kinds of technology, in that it's degrading executive cognitive capacities. And that's not the sort of thing that just simply gets replaced by the process of extended cognition. Okay, so now I think we can formulate what's going on here. The goal of education isn't just about useful knowledge and skills, it's about how cultivate, it's fundamentally it's about cultivating fundamental, it's cultivating good intellectual character. That means cultivating these executive cognitive skills. It's not really about the domain-specific skills, it's about these managerial skills. The problem with AI, though, is it's used in a natural way. It will prevent students from doing the very kinds of activities that would cultivate those skills and therefore would lead to degrade them. So, I mean, take the essay writing case. Obviously, not all education is about essay writing, but I think this point can be extended to lab-based views, design-based views, and so on of education. In any case, let's take the essays. I mean, sure, we want people to write essays. We mark the product, the essay itself. But the reason we said essays isn't so much because of the product. I mean, that's the obvious reasons why that's the thing that gets marked. But we want people to write essays because we believe the process of writing essays is important. We want them to do the thinking, the drafting, the redrafting, the reasoning, the imagination. So we think all these things, this productive struggle students engage in when they're writing the essay, that's part of what is important, the essay writing. And why is it important on the student? Well, because it's developing these executive cognitive skills, developing good intellectual character. But that's why it's significant the AI isn't just helping students to write essays better, but it's actually writing the essays for them if used in this most natural and straightforward way. Okay, so now I think we're in a position to work out how we should respond to the challenge. So first, how should we respond to the challenge? First thing is we shouldn't just treat it like another form of technology. So on the view that I started out with, the faulty view, if it's just technology, well then we should just come up with strategies to integrate it and just work out how to integrate as one would ordinarily would with other kinds of technology. We just have to prepare ourselves for the fact that it's a big technological change happening very quickly, so it's going to require a lot of change very quickly. I don't think that's the right way to think about this. We have to understand that AI poses a different kind of change. It's not, on the picture here, it's the introduction of someone's introducing an abacus into teaching. That's not the right analogy to have here. I don't think it follows from what I've been saying either that we should prevent students from using AI altogether. The claim is not that AI, in general is problematic. The claim is that there's a certain natural usage of it, which is problematic. So what we need to do is to find ways to prevent that natural usage, to get it used in a different way. And besides, in general, it's not a good idea to deprive students too cool from technology, the use of technology, right? The students are going to live in the AI age. It's going to be there whether they like it or not, whether we like it or not. So students who don't adapt to that are obviously going to be at a disadvantage. We don't want that. Okay, so how should we respond to it? I want to make some 2 or 3 very suggestions. The first is that I think we need to have sometimes called cloistered learning. So, if we take seriously that there is this fundamental challenge posed by AI, then I think we're going to need to have instructional spaces where the AI is not present. Instructional spaces which are specifically focused on the cultivation of intellectual character, on the cultivation of these executive cognitive skills, where we recognize that the AI is a potential barrier here. So we need to have these spaces where students are required to think, to reason, to argue, to debate, and so forth. The very kinds of skills that we think are important for developing executive cognitive skills and therefore good intellectual character. So there's what I'm going to call it cloistering, as in the monasteries of old. Here's the difference the monasteries of old, though. The monasteries of old, that's a sort of total cloistering. That's, removing someone from everyday life. That's not what's being proposed here. Cloistering is going to be a temporary removal. We want students to be back out in what's some contexts called the starship. There's a really nice essay, you should look it up, by Neil Ferguson, the historian. He talks about he says the students of today, since they're faced with a choice between the cloister and the starship. He thinks that normal life is what he calls the starship, all this technology available to them. But the problem is they don't know how to use it. And so that's why we also need the cloister to separate them out from the starship. And I think there's some truth to this. So we want the students to be in the starship as well. We want them to have access to technology. We want them to make sure that we're cultivating their good intellectual character in a way that's such that when they go out into the starship, so they then engage with technology, they can use it in ways that are different. And by the way, I see this in, I'm going to get to the stuff we've been doing at UC Irvine, but what seems clear to me is that once you start educating along these lines, and this is what we've been trying to do lately, students change their practices, and we're testing for this now. This is an empirical point, but it's a correct one. Students, once they recognize the utility of this, they change their practices and how they use the AI. So there's a way to get students to use the AI that enhances their intellectual character, their good intellectual character, rather than mine. This leads me to the second point. You can educate for good intellectual character without teaching the theory. And this is generally true. There can be an educational practice. You don't need to teach the theory behind it. But I think in this case, actually, it is important to teach the theory. Remember, the focus, my focus is higher education, where I think it's very straightforward to teach the theory. I think this is going to be very important if we do go down the cloistered route. We have to explain to students, why are they being cloistered? What is it? I don't think cloistering is going to work if students don't have an understanding of why this might be necessary and what it is we're trying to achieve in the cloister. In any case, there's a lot of evidence to suggest, in higher education, that there's an advantage to students having this theory anyway. The students benefit from having the sort of conceptual scheme to make sense of their education in those terms, right? So, students' educational outcomes are improved if students have the conceptual scheme where they can think of what it is they're doing when they're being educated in terms of these overarching goals. Related to this, I think we also need an empirical study. I mean, the stuff that I'm suggesting here, the proposals, of course, they're quite coarse-grained, inevitably. How do we turn the coarse-grained ideas into fine-grained ones that can be employed in policy? Well, it seems to me we need feedback loops of an empirical nature. We need to plug these in, test them, see their effects, refine them. I mean, there's lots of questions we might ask you. I mentioned before, we focus on essay-based disciplines. What's disciplines on essay-based? How does that affect AI use? How does educating for intellectual character change AI use? Right? I mean, I suggest that it does in a positive way. That's obviously an empirical claim. Go back to that. What are the effects that cloistered learning is affected and so on? As it happens, we're doing all these things right now at UC Irvine, the project that I'm running. It's called the Anti-Teacher Versions. That's because the mascot for UC Irvine is Pete, the Anti-Teacher. So what we're doing now since 2019 is that integrating we're focused on intellectual virtue, but intellectual character broadly anyway. We're embedding that into the curriculum right across from orientation through to graduation. This idea of educating for virtuous intellectual character, including teaching the theory. So students it's not just which we're thinking of their education in those terms, but we give them the resources to think of those education in those terms. And we're also empirically evaluating its effects, which have been very positive, by the way. I mean, positive in a very significant way. When you educate for in this case, virtuous intellectual character, you get positive effects, educational outcomes, which is stable across demographics, which is actually quite significant. Normally, I'm sure many of you know this, when you have an pedagogical intervention, of course you get positive effect. Right? That's kind of the norm for interventions, because you're intervening, you're doing something new. But usually, for example, it's the students that are already doing well, gain the most, and the students that are doing badly gain the least, for example. But you don't get those effects here. It's a pretty stable script, which is very significant. But also, interestingly, students who are educated for this in this way, have this conceptual scheme at their fingertips, they use AI differently. They're not inclined to let the AI write the essay for them, or the AI do all the work for them, because they see the significance of the productive struggle involved in being engaged in these kinds of cognitive activities themselves. So already we have, some empirical support for the idea that going in this direction would lead to positive use of AI in a way that would promote enhance intellectual character development and not undermine it. Okay, so conclusions. I've said that if we respond to this revolution, we understand what it is, and that requires us having a correct conception of what the overarching epistemic goals of education are in terms of, as I've suggested, the cultivation of good intellectual character. And I think that the threat that it poses is distinct from the threat that technology otherwise imposes in educational context. And that's specifically because it undermines the cultivation of good intellectual character, the development of executive cognitive skills. That's what makes it different from other kinds of technology. And that's why the strategies that we need to employ educationally in order to deal with this can't just simply be using, just adapting technology in the usual way. We have to have something more radical. We've got to have ways, as I've suggested, of separating students out from the technology so we ensure they cultivate the good intellectual character, and then we have to give them the conceptual scheme where they can understand how they can use AI in ways that further cultivate that intellectual character. Thanks very much. Okay, that's done.
Thank you very much, Duncan. So if you have questions, I would probably suggest stepping closer to the computer so that he can hear you. Let me start with Mona.
Hi Duncan, how are you?
Hi, Ryan.
Hi, let me see you.
I can see you now. Can you see me?
I can, that's right, yes.
Okay,
I'm
good.
not looking in the right way, now I'm looking at it. Now I look like I'm looking at you, am I right? So here's my question. So I'm wondering, we were using these essays basically because it was, as it were, a good essay was a proxy for a student that knows how to argue well for a thesis, right? So maybe it's just the wrong proxy right now. So instead of trying to, as it were, trying to teach them how to use AI to write these essays by first isolating them from technology and so on and so forth, maybe we can just develop a different way of teaching them the arguing skill rather than, or seeing if they have it rather than through essays. So I'm wondering, one obvious way is to just argue with them, right? So instead of asking them, write me an essay in order for you to think really hard about some arguments, how about we just sit down with the students and we argue with them about something in a group over the table, which is basically what we do professionally, right? So professionally, we just sit down and we start arguing about stuff. So I'm wondering if it was just a proxy that was useful back in the day and that we should just abandon. So it's not the AI's fault that we're losing brain matter, but it is the fault of the fact that we don't use it, as it were, in a different way.
Yeah.
Sorry.
I mean, that's true. And some people have done this, right? Some people have actually have taken that step. So they're moving like oral exams. I know some educators are doing this, they don't want the essay anymore, they want these oral tests, which is kind of like testing that. Here's my hesitation. I think the essay is a wonderful thing. If done well, obviously, not the since the dawn of time type essays that we get for undergraduates, not those ones, Descartes, Cartesian type essays. But when it's done well, let me give you an example. So right now, for a few years now, actually, I've been doing a flipped classroom, and if you don't do this, I'd recommend it because you can record your lectures. There's like give lectures. I don't know why you just record them. They watch the recording, and then they come to class. And the purpose of the class is just, as you say, to argue, right? So you get them into this argumentative mode. You spend the time arguing. This is basically like the cloister. And by the way, I begin with the AI lecture as well, right, to try and get that thought into their minds quickly. The students who run with this, and this is why it's significant, the students who run with this write fantastic essays at the end. It's wonderful to read. Like they're original and they're not this kind of like gumph that you normally get, which is just regurgitating stuff. They've really thought about it and they've thought through and they've kind of struggled. You can see that they've charted a course through. And I just think this is a wonderful thing. So I'm a big fan of the essay, and I don't want the essay to go. I mean, what's right in what you say is that we shouldn't, as it were, assess it merely as an output. What we were interested in was the needs of the output. So we have to make sure either at least that the needs are there, or we have to assess the needs. I mean, that could be another way to do it. But for my purposes, as long as I'm happy to meet, like in this case, that class, I can see that I was there, and I can see the needs, but I don't need to assess the needs. I can now focus on the output, because the output is representative of the needs. But in other cases where I'm worried about that, then maybe I might want to assess the needs of the output too. Yeah, so I'm sympathetic, but I love the essay, so I don't want to get rid of the essay.
Thanks.
Chris.
Hey, Duncan. Thanks. That was really interesting. So I was wondering about the difference in kind claim that the AI challenge poses, and so basically I have kind of a worry from two directions. A, whether this the fact that there is a natural use of AI is enough for this difference in kind point, and whether you can't use AI in a sort of character building way as well. And so I was thinking look, you might think that an incredibly natural use of the phone is when you don't have the answer to a question in an exam, to phone somebody who has, and get it from them. And that's in part why we don't allow phones in exams, right? But that doesn't mean that there is a specifically this use sort of establishes a difference in kind, right? This natural use of the phone establishes a difference in kind for the phone. And I wonder whether, how the AI is different. And on the other hand, I was thinking about my son, who's now into basically vibe coding games for Roblox. Right? So he wants to make these games, and he uses Claude or ChatGPT to write the code. But I think it's still an incredibly good thing for him to do, because if he didn't have the AI, he definitely wouldn't be doing that, because the coding is much too complex for him. And he's still going to be involved with adding features, finding stuff that works, and sort of using the AI in ways to get what he wants, to get the product that he sort of envisaged in his head or develops as it goes along, in ways that I think are really good for him and for his cognitive capacities and his character building. So I wonder whether basically we're sort of not just but there aren't ways of using AI that are actually good for character building, for the sort of thing that we want from them. We just have to make sure that we use it in the right way, so to speak.
Yeah, absolutely. So I wasn't suggesting AI is bad. I mean, of course it can be used well. And certainly, so in terms of expanding what we can know and what we can do, of course, like all technology, it's very useful on that score. And indeed, it can even be used to enhance cognitive character. My thought was just that, this appeals to the natural. So the natural use, so take the, just focus on the essay case, right? The students who think to themselves, well, why do the reading? The AI can summarize it. Why write the essay? The AI can write my essay, and so on. I think that's an entirely natural way of using technology, right? It's just that I get, unless you already have intellectual character, you see the point of intellectual character, or you particularly see the point of intellectual character as a goal of education. I don't know why you would care. Why would you even have this thought, right? Like, there's some task I need to do, the AI can do it for me. Well, why not use the AI? So that was the thought and then of course the idea is doing that undermines the executive cognitive skills. So yes, I was fine with that. And then the other thing was but the idea is, okay, so the idea is that once you've got the good intellectual character, then you can see the point. You can see the point of why now I should engage in the productive struggle. Now it is something that can be done trying to understand this for myself. So, okay, that's one point. Second point was the difference between educating for knowledge and skills versus character. So so think about the phone, right? So part of my point there was that, like my parents' arithmetic, I don't think anything particularly is lost by the fact that the 1930s they had to. There's a reason why they drilled in arithmetic to. Aside from anything else, they didn't have shilling, they didn't have decimalization yet. You had to do complex arithmetic even to like a shopping back then. So I can see why they drilled it, and there was a point to it. But of course, that point is lost later. So why we don't drill it in, and now we can just use the calculators and so forth. And that seems to be that's absolutely fine. Right? My point there was that there's no real loss. It seems to me. And one way of using AI would be a bit like that. It would be like, I think the way your son's using it sounds is like, there's certain tasks before maybe they couldn't be done, or there's no point to doing it, or it had to be done by yourself before you have to do the coding yourself. Let's say, now you can do the coding for you. That's the sense in which it's fine. But what I was interested in is more targeting, well, what is problematic? What gets problematic is when it affects the cultivation of your executive cognitive skills, and that's when that's like when the AI stops you writing the essay, or stops you reading, or stops you trying to work things out yourself. Knowing the answer, in a sense, is kind of like, so you mentioned the exam, right? So assessment versus learning. Obviously, we don't have phones in the exam because part of what we're assessing is that they learn, certain facts. Let's say the phone will give them the facts, but when they're learning, it doesn't matter that much, right? Where they get the facts from, when they found that, to the extent that all we care about is having the facts, it doesn't matter that much whether they got them from the phone, the textbook, the teacher, what have you. But that again, when we get back into a view of education, it's just about giving you the domain-specific knowledge, the domain-specific skills. What we're interested in ultimately isn't that. It's the cultivation of intellectual character, which is more than just knowing specific facts and so on. And so once we build that in, then we can start to understand why certain kinds of technology might be problematic in ways others aren't, precisely because they get in the way of the cultivation of intellectual character. So that's quite convoluted, but the reason why it's convoluted is I think there are various strands there in response to your question.
Okay.
I wasn't expecting a thumbs up.
Adam. Yeah, maybe you see there too.
Hey, my first objection is that you haven't aged a day in 20 years, and that seems like that should be legal, but I'll set that on the side. Lovely. One little thing about the Cloister thing. So there's this stuff on information overload, and the thought is that, okay, our cognitive capacities just didn't evolve to be swamped with a bunch of information everywhere, and that's one of the reasons why we fall for tricks with AI and such. If we think about that, and then we look at the Cloister line, I just wonder what you think, pressed at the thought that maybe the Cloister line is vulnerable to a similar kind of charge. And the thought would go as this. If we're doing the Cloister and we're cultivating intellectual virtues streamed off from a bunch of AI, and then we become good and develop those virtues there. Then when we then mix them with the AI, we sort of go out into the world with our virtues after the cloistering. The thought might be that by parity of reasoning, we might be these virtues in an environment that's different from the one in which we acquire the virtues, or something like that. So to try to like spin a parity argument like that.
Yeah, good. I mean, I think this is where certainly the virtues are very interesting, and probably the executive cognitive skills in general, I hope. But certainly the virtues, they don't seem to be domain specific. So certain kinds of cognitive skills, I can imagine, are very much environment relative. So you get good at it, you get good at it within their environment, then you plug them in a different environment, and suddenly they struggle. But they don't seem, I mean, we talk in education circles about these transferable skills. Executive cognitive skills are the most transferable skills it seems to be that there are, precisely for that reason, right? That whatever you do in life, they're going to hold you up, they're going to hold you in good stead, precisely because they're not specific to the domain. So I think actually, I would turn that point on its head actually and say there may be some features of these skills which would mean that they would, by their nature, would be resistant to precisely that kind of work. In a way that clustering, let's say, for more specific domain-specific skills would be pointless for partly the reason you give.
That's interesting.
It's like an exam you can call about
it.
Great talk, good to see you again. So, yeah, I was just wondering about these executive cognitive skills that are sort of necessary in the intellectual character building. So one approach was this thing, we talked a bit about these spaces where you could teach the kids the theory and these sophisticated concepts, but just sort of practical questions about that. So I don't think that would really fly with the SQA. I don't know what it's like in California. You might remember in Scotland, we had super, detailed and prescriptive and so on around what they have to learn of literacy and numeracy at each level and the progression and so on. So I was wondering if there could be another approach whereby you could instill these higher order kind of executive cognitive skills, but via or through instilling and cultivating these more kind of, as it were, first order skills around numeracy, literacy, and knowledge and so on. Because it just seems like it is an ideal scenario that you're describing, but I don't think it would fly with many of these, SQ, Scottish Qualification Authority, and these other, I don't know what it's like in the States, maybe it's very different. It seems like a very ideal scenario. I think there's a way of doing it indirectly through these other first order skills. That's what I was thinking. Thanks, Duncan, it's great.
Yeah. Yeah, no, this is a big debate. At what point can you do this? Like, as I say, my interest is in higher education. I think in the higher education context, it's pretty straightforward. Of course you can do it. In fact, we do it. You can teach the theory, like, why not? The higher education students, they can handle it. It's been done in schools, and it's done very successfully in middle and high schools. I can give you two examples that, I don't know if you know this, there are two schools just up the, so one of the main collaborators on this is Jason Baer, who's just up the road here. And he has this rare distinction. He founded two schools. I don't know if people know this, he's very modest guy, so he doesn't trump it enough. They're called the Intellectual Virtues Academies. They're proper schools, middle school, high school. The whole curriculum is designed around educating for intellectual virtues. And they're amazing schools, and they've been studied, huge effects. And the students are taught virtue theory right from the off. It's embedded into all their lessons and so on, and it's been a huge success. So it can be done. Now, I think your question becomes elementary, right? So we can go to middle school, which is like kind of like, I think it's like 10, 9 or 10 sort of age. That's it's not just doable, it's been done. Okay, admittedly in Long Beach, I don't know, that's probably a bit of a gentrified area, I don't know. Can you go even earlier? I suspect you could. I mean, there's two ways to go. One is the way you suggest. And what a lot of people have talked about this is you try and, because remember, we're not opposed to cultivating knowledge and skills, right? We want to do it within a certain framework. So how to bring that into arithmetic and so on. And I think you can think of it that way, because what you do is you think like in terms of like resilience. I mean, we do this in elementary school, right? We try and teach kids character in the sense of, like being resilient in the face of obstacles and so on. Well, that's kind of like close to intellectual tenacity, which I think is an intellectual virtue. Or we might teach them about, like, you know, respecting others and listening to others, being aware of one's own, you know, propensity to error, you can use those terms, but like intellectual humility, open-mindedness and so on. So I can see ways of doing that like that. There's a more radical way though, which I'm kind of pretty much sold on, which is that I tend to think that teaching in its purest form is just educating for intellectual character. So there's, you know, once you start to teach in a way that isn't really specific to any kind of discipline, so there are various practices. A lot of the philosophy in schools aimed at the kids is like this. You're not teaching philosophy in the sense of teaching them, you know, like Plato said this, right? You're not teaching them any facts at all. Rather, you're just teaching them how to sort of think. And you're giving them like little puzzles, and then you're talking about how they're responding to it and so on. And what I think you're doing there is you're giving them these tools to think about thinking in a way that isn't domain specific, which I think is really, it's just, you're thinking, you're just helping them to cultivate their intellectual character. So I think it can be done. Actually, a lot of people think that the best age to introduce this is about 7. So 7 is an age, 7, 8, some people as low as 6, but it's a kind of a developmental age where most kids will have enough of the relevant sort of basic capacities, whether they can engage in precisely this kind of abstract discussion. You know, maybe they don't have, maybe you're not going to get like theoretical terms and things like that. That's not going to work. But like proposing them like puzzles and getting them to talk about the puzzles and getting them to engage in discussion actually works very well. They're very open-minded, they're very elastic, you know, and you can start to think about, so you're not teaching the theory now, but you are educating explicitly for intellectual character in a way that's not domain specific. So I'm kind of sold on that, but even if, you know, one's skeptical about that, I can imagine people are right, but then you go the other route. I think then you start to think, well, the kinds of things we do in the domain specific sphere, like trying to get students, like, you know, elementary students to be resilient, is really, you know, that's code for developing intellectual character. It's just we're going through a more familiar route to do that.
Great, thanks again.
So, hey Duncan, good to see you.
You too.
So, I love the idea of cultivating executive cognitive capacities and how your sort of thinking is built around that idea, both in terms of like the diagnosis of the problem and also the solution to the problem. So I'm all on board with that. So I don't know if I'm just thinking about packaging or marketing, but I went to the UCI site, the Anteater site, and the virtues that are listed there are curiosity, integrity, intellectual humility, and intellectual tenacity. And those sound more like Zagzebski type virtues than Souza type virtues, but you know, executive cognitive skills, those sound more like Souza type virtues. And I think, you know, Jason does the same thing. Like when Jason's talking about intellectual virtue, he's talking about Zagzebski type virtues for the most part. So I wonder if there's a little bit of a disconnect there. But then the other disconnect I was seeing anyway was, at least on the face of it, when you cite Newman and Dewey and this like think for yourself slogan, that sounds to me like a kind of outdated individualist type approach that I know that you don't buy into yourself. I mean, you're you know, all about social epistemic dependence, including social epistemic dependence. So I'm wondering, I don't know, I don't know if I'm just complaining about the marketing, or if I'm asking about like what are we really talking about here in terms of substance.
Okay, yeah, great, thanks. That's really useful because what I was doing in the talk, I was trying to preach to a broad church. So there are people like Siegel, Harvey Siegel, who advocates for what he calls critical reason. Critical reason is a sort of cluster of what I would call executive cognitive skills, but they're not the intellectual virtues. They don't have he doesn't, in fact, he doesn't like the intellectual virtues because he doesn't like the idea that because they have a motivational component to them and they have a value component to them. And he doesn't like that. He thinks education shouldn't even have that, right? That's too prescriptive. And that's one of the sources of disagreement between the two camps. So his is more a broader conception, but it is about character. He just thinks that these are very high-level cognitive skills and character skills. And he would have, in terms of the sort of virtue debate that you're talking about, he's more on the side of the Sosa than the Zizepsky. The way to think of it is Platonic versus one way to think of it is Platonic versus the Aristotelian, right? The virtue stuff, the bear and myself, that's the intellectual virtues in the Aristotelian sense. Got these motivational components, axiological components, promotes flourishing and so on. The broader sense is the Platonic sense of the virtue, which doesn't incorporate, the broader sense of virtue where athletic, being good athletically could be a virtue and so on. So that would be compatible with the Siegel type view. A lawyer could be a great lawyer, lots of great critical thinking skills, but they don't care much about the truth. They just care about winning arguments, let's say, or looking good, or whatever it is they might care about. They don't have the intellectual virtues. But that, from Siegel's point of view, that doesn't matter. It's up to them what values they have. We should care about that. So that's the big divide. And I was trying to say, well, look, we can have, the point I'm making doesn't depend on where you stand on that divide. I'm on the virtue side. But if you're on the Siegel side, I think you should make the same point I'm making. We're standing together, at least on this issue, right? That was the first thing. And that's where when you go to the anti-virtue side, you've got intellectual virtues, because we are specifically educated with intellectual virtues. And I do think that's important. I could make a case for it if you want. In particular, I think you've got to educate for this, the truth is good. And I think that's you can't do it without it. I think Siegel's kidding himself that we could do this. That we can really cultivate these higher order traits without also cultivating a consent. I think Aristotle's right about that. In fact, I actually think the desire for the good is itself a kind of sort of meta virtue, because what we're cultivating is a kind of a virtuous desire for the good of truth. Truth, as it were, is the intellectual guise of good. That's the way to think about it, something like that. And so, aphronesis, our practical wisdom, is geared towards an appropriate valuing of that good, and in this guise, in this context, it's under the guise of the truth. So yes, that's why I think all that. And then on the individualism stuff, well, first thing I'd say is, remember, I'm thinking more higher education. I think the individualism is less problematic there. I mean, of course, I buy all the social epistemic stuff, but the idea that we enabling people to think for themselves seems to me very valuable in the higher, in the following sense that there's something problematic about activism, let's say, in higher education. Certainly, in fact, let's even make it more restricted. Activism in the classroom in public higher education, kind of a bugbear of mine, right? That's not our job. It's not our job to tell you what to think, right? Our job is to help you to think. And help you to be good thinkers, and then you work out for you. That's the bit that Siegel's right about in terms of values. That's not what we want. Does that have, and all the thinkers I mentioned agree with that. I mean, they all come from different perspectives, hard left, and mostly hard left, sort of centrist sort of perspectives. But they all come, I would say they all come out of the same liberal tradition, which comes out of the Romantic period. I mean, blows people's mind when you remind them of this. Marx comes out of the liberal tradition, right? I mean, left libertarianism, there's a reason it's left libertarianism. It comes out of that, realizing capacities and so on. I think Marx would have been absolutely appalled by Bolshevism or any kind of vanguardism of that kind, right? Because it's not about respecting the individual. So to that extent, individualistic. But I think that kind of individualistic point is compatible, can remain compatible, all the other kinds of social epistemic dependence. Just as, for example, we've got a social epistemic dependence here on technology, right? But we also want the executive cognitive capacities to be such that the technology is used well. The individualistic point, as it were, dovetails with the social epistemic point. Now, when you get lower than higher education, You know, do we have less of individualism? I mean, that's an interesting question. I'm inclined to say no, but I can see the arguments are a bit different there. I mean, certainly through maternalistic or paternalistic arguments in education, when you deal with children, look more plausible and more compelling, I think, in a way they're not with higher education. I think we should resist them there, but I can see a case there. So I think that answers your two questions.
Yeah, I'll give you the thumbs up too, if you can, yeah.
So Monica has a follow-up, please.
Hi, Andrea, I have a follow-up. So, just like John, I'm also wondering if we're not teaching them to be vaccine hesitant. So I'm wondering, even in higher education, it seems to me, let's try an unproblematic example and then move back to philosophy. So it seems to me like in medicine, what we want to do is teach them everything that we already know about medicine. So teach them, to believe that insulin is good for diabetes and they shouldn't go buy themselves in the world and try all other cures until they discover insulin themselves, because that seems like a bit of a waste of time, right? So we want to, teach them ex cathedra from expertise, and at the same time, of course, enable them to think such that they can build on that expertise that they built over so many thousands of years of medicine, right? So you might think that the same is true in all domains, and in particular in higher education, where the expertise is much more complex than in primary school, right? So I think that I would have thought that it's exactly flipped to what you were saying, that actually the more complex it gets, the more we want to teach them what we already know in order to be able to make progress by then building what we already know, rather than sending them into the world to inquire once again in what they have already found out. You know what I mean? So similarly in philosophy, maybe it's not yet world consensus that internalism is false, but I think we're pretty close to that. So maybe we shouldn't start from Descartes again to try to figure out, if we doubt everything, what happens, right? So we made some progress. We've at least established some negative results. So maybe we should tell them, look, this theory really doesn't work. Now go ahead and think for yourself together with other philosophers about what a better theory might look like. You see what I mean? So I'm thinking that maybe one important skill is actually to teach them to listen and believe in expert testimony.
Yeah, exactly. I mean, the first thing I say is that I'm not suggesting we don't teach domain-specific knowledge and skills. Of course we do. The question becomes, is that all we do? Right? Some people think that is all we do. And I want to suggest, no, we do that as a means to also cultivate a good intellectual character. The domain-specific stuff will come and go, right? People, as Aaron has shown, a few years after college is gone for most people unless they're using it. The character stuff will remain. And it's the character stuff that's going to stand them in good stead. So I wasn't thinking that education for intellectual character is opposed to teaching, and including in teaching it as fact, right? If it is the appropriate expertise. And also, I think the point about expertise is you need good intellectual character. It seems to me it's not enough just saying to people that these are experts, and we should trust the experts. I think it's more important to get that in epistemic embedded, and to have people understand, why should I trust it? Understanding your own cognitive capacities from a sort of managerial point of view, and how you should manage your cognitive capacities in terms of when to trust experts, when to not trust experts. So ideally you want it embedded in that way. You don't, like, for example, we don't just want people who just sort of passively always trust anyone who goes by the name of expert, for example, right? That wouldn't be good. Particularly since not everyone cast themselves as an expert is an expert, so we want expertise to be at the heart of it, but we also want to give people the very kinds of high-level cognitive capacities such they know how to deal with expertise. And I think that kind of education would be one that cultivates good intellectual character.
Then I'd like to also ask a question. So I completely agree that educating for character is very, very important. And I also like the point that unlike other technologies, AI does not look like a cognitive extension. It cannot be integrated. It only helps atrophy our internal abilities. Now, even though I definitely agree that educating for character in school would be useful. I don't know what to think about, for instance, higher education, specifically about philosophy, where essay writing is very, let's say, a big part of what we do. And I worry that even if someone has picked the character, to then go to university and just use this character to then write philosophy essays by using AI, people are sometimes lazy, but not for epistemic reasons. Maybe life gets in the way. Many students may have part-time jobs, full-time jobs. You ask them to write an essay, they might eventually, even if they have a good character, just have to, because they're interested in the market as well, for practical reasons. So I was wondering what we do in those settings. And one idea is to return to the extended and embedded cognition stuff, and then try and see whether we can design a setting and a technology that would actually help them use their character alongside AI. So, for instance, why not have some kind of LLM that instead of giving you responses that look like a whole essay, you just spit out small paragraphs that you can somehow then engage in a feedback loop to write up the whole essay for yourself, and do that within the educational setting. So, within the classroom. Would that be completely stupid, or do you think it could also somehow help something like this?
Yeah, great. I think that is partly what the future may be. Just on the point of the, like students having other reasons for writing essays, I think that's, we have, at UCI, we have, our demographic is such that we have a lot of students who are transfer students that come from community colleges. So they often are doing jobs, or funding themselves, low incomes and so on. So here's, I think, there are certain practical things that we can do to help those students. I mentioned earlier the flipped classroom, right? Notice how a flipped classroom helps a student like that. They watch the essays, they watch the lectures whenever they want, right? It's just there, right? They don't have to. I think for students like that, you limit the amount of time that they have to be like timetable time, right? Because that's what they don't have. It's not that they often, they're willing to put the time in, they can't be there for this particular lecture, right? Because they're working, what have you, but they are interested. And I think, so that's one thing, you're building flexibility for them. And also, of course, you have to build in sort of motivation too. You've got to explain to them, like, why is it important to have these debates in class? Why is it important to have them? So I think there are ways you can mitigate against them. But also, I think the way we go with education in terms of the use of AI will be exactly what you were talking about. In fact, it's kind of happening now. Like, there are people developing sort of bespoke. This is supposedly for the early embers of sort of agentic AI. The idea is you have like a sort of bespoke tutor. The tutor gets to, it's an AI tutor, it gets to know you and what your interests and so forth, and it asks you questions and interrogates you about what you're doing. So you can imagine something like that, which, as it were, doesn't let you be lazy. Right? It doesn't let you just, come up with, like, every time you write something, it interrogates you about it, and like, you've got to answer questions about it. I mean, some people are trying to think of the essay. I mean, I like the essay, I don't want to do the essay, but some of the things like, instead of essay assessment, you have something like this. Like, a bit like an oral exam, except it's the AI doing the oral exam. And it's typed, let's say, you type answers in. I mean, maybe you can do it orally, I don't know. If the voice recognition software is good enough, you can do it like that. But type's probably better because you get people a chance to sort of think before they type out what it is they want to say in response to questions. But yeah, the AI is being a tool, and it's important it's bespoke, where it gets to know you. So it gets to know, like, what are the stuff, what's the stuff that you struggle with? What's the stuff that's your blind spots and so on? And then it works on those to help you develop. And I think that would be, but again, I think that works best if it's being done as a way of cultivating good intellectual character. And I think that's, the natural way to think about what we're doing here, as opposed to offloading, things that would normally cultivate good intellectual character to the air. Right? What we're trying to do is circumvent that by bringing in these practices that force the student to develop the executive cognitive skills, right? We're using the AI to do that.
Any more questions? Okay, so, okay, let's thank Duncan once again. Thank you very much. Hope to see you here next time.
Good to see you all. Yeah, I know. Every philosophy should get out of it at some point.
Bye-bye, Duncan.
Thanks. Take care, everyone.
You too. Okay, we're done. Thanks, everyone, for the very, very nice contributions. Knowledge.
I think we spent it finally. I think it's gone. The digital knowledge.
And many, many thanks also to your library
It's finally done.
Also, thank you to
the space.
Ms. Jerry Copperly
Yes.
for this amazing.
Exactly, exactly. The honor is ours. Thank you, thank you, thank you.
I want to see that budget report on zero. You guys.
Don't worry, we take care
I want to see it on minus, that's what I was.
This can stop as well.
So, John.